The deepest reaches of space are cloaked in a profound, silent darkness. Far from any star's warming glow, an endless night stretches out between faint pinpricks of distant galaxies. In this infinite cosmic midnight, one can feel a sense of both tranquility and mystery. It is a silence so vast that it humbles the soul, inviting contemplation of the grandest scales of time and existence. Time feels almost suspended in this emptiness. Without reference points, minutes and millennia could pass unnoticed. Yet we know, as distant observers, that time is flowing and changes are happening in this darkness on scales we can barely fathom. Drifting gently through this darkness, imagine yourself as a tiny traveller in the void. The stars around you are sparse, mere wisps of light, years apart. The Milky Way's soft band glimmers far behind, and ahead lies a deeper shadow. There, at the centre of an unseen galaxy, something waits in the darkness. There is no light to announce its presence, yet you can sense a great mass ahead, a gravity pulling at you subtly, like an undertow in a dark sea. You are approaching one of the universe's most enigmatic phenomena, a black hole. Invisible against the black background of space, a black hole reveals itself only by the gentle distortion of starlight around it. Like a piece of the universe missing, it is a region of space where the usual rules break down. As you float closer, you notice strange things. The stars behind it seem to warp into rings of light that curve around an empty shadow, a gravitational mirage. You are witnessing the light of distant suns bent by the intense gravity, forming a halo around the unseen core. It is both beautiful and eerie, as though space itself is whispering its secrets. Black holes are often imagined as cosmic monsters, devourers of worlds. But in this calm journey, we will come to see them in a different light, or perhaps in a different darkness. Rather than fearsome destroyers, we can think of them as silent guardians of deep time and gravity, gateways to understanding the extremes of physics and the fate of the universe. In this tranquil expedition through knowledge and imagination, we'll explore the nature of black holes, the flow of time around them, and the distant future that awaits when the stars themselves have faded. Our path will wind through real science and speculative wonder, from how black holes form and evolve, to what they teach us about the nature of time, and onward to profound questions about the end of the universe and beyond. Allow your mind to drift as we embark on this voyage. Feel the gentle awe of the cosmos around you. Each concept will unfold slowly, like the gradual dawning of stars in a twilight sky. Together, we will journey into the heart of darkness, but not a darkness to fear. Instead, it is a darkness filled with wonder, a canvas upon which the universe paints its most enigmatic stories. So, under the soft blanket of stars, let's begin this gentle odyssey into gravity's darkest realm and time's farthest shores. Welcome to an odyssey across space and time. A calm exploration of black holes and the eternal nightfall that may one day settle over all things. What exactly is this invisible object we approach? A black hole is not a solid body or a hole in the usual sense, but rather a region of space-time where gravity has become overwhelming. It forms a one-way trap in the fabric of the universe. At its boundary, the event horizon, nothing that crosses can ever return. This boundary is like a point of no return, often described as the surface of the black hole, although it is not a surface you could touch. It's an imaginary sphere surrounding the black hole's center, defining the zone where escape becomes impossible. If you drifted past this point, even at the speed of light, you could not get back out. Light itself, the fastest thing in existence, once caught, spirals inward and is lost. That is why the black hole is truly black. It reflects no light, emits no light of its own, at least not directly, and thus becomes a dark void against the starry background. We can try to picture the event horizon. It's often said to be like the mouth of a tunnel with no exit, or the edge of a bottomless well. But unlike a normal tunnel or well, crossing this edge doesn't feel like hitting a physical barrier. If you were in a spaceship and crossed an event horizon, you wouldn't even notice the moment you passed it. There is no signpost in space saying, "Here begins the black hole." You could cross it without immediate fanfare, yet your fate would be sealed. The horizon is defined by destiny rather than touch. Once inside, all paths lead inexorably inward toward the core. And what lies at that core? According to Einstein's theory of general relativity, if you continue all the way down, gravity grows stronger and stronger, compressing matter beyond any known limit. The equations suggest that at the very center of a black hole lies a singularity, a point of infinite density where space and time themselves may cease to have conventional meaning. In this single point, all the mass that formed the black hole is concentrated. Gravity is so extreme there that the normal laws of physics break down. It is a place we cannot truly imagine, and perhaps a place that does not even physically make sense, a sign that our understanding of physics is incomplete. It's as if the universe hides its ultimate secrets behind the veil of the event horizon, keeping the singularity out of our reach. Historically, the idea of an object so massive that light could not escape dates back to the late 18th century. John Michel, an English clergyman and scientist, and Pierre-Simon Laplace, a French mathematician, both pondered the notion of dark stars, stars so large and compact that their escape velocity would exceed the speed of light. These were early musings, long before modern physics, imagining a gravity strong enough to trap light. They lacked the detailed theory we have now, but it's fascinating that even then, thinkers were flirting with the concept of a black hole. It wasn't until Albert Einstein published his general theory of relativity in 1915 that a firm theoretical foundation was laid. Soon after, in 1916, physicist Karl Schwarzschild found a solution to Einstein's equations, describing the space-time around a very compact mass. Essentially, the first modern description of a black hole, though the term wasn't used yet. For decades, black holes were considered mathematically interesting, but perhaps not real. Some scientists like Subramanian Chandrasekhar and J. Robert Oppenheimer showed how massive stars could collapse under gravity, hinting that nature could indeed produce these objects. But many in the scientific community were skeptical of such frozen stars, or collapsed stars, as they were sometimes called. The name black hole itself only came into use in the mid-20th century. It's often credited to the American physicist John Archibald Wheeler, who popularized it in the 1960s for its catchiness and brevity. Before that, these objects were discussed with cumbersome phrases like gravitationally completely collapsed objects. Black hole captured the imagination, a dark void in space, and the name stuck, giving a spark of intrigue to this deep idea. One more thing to note about real black holes. Most of them are likely spinning. The black hole we described earlier was a non-rotating, simple case for the sake of understanding. But stars rotate, galaxies rotate, and when a star collapses into a black hole, it usually retains a lot of that angular momentum. A rotating black hole is described by the Kerr solution of Einstein's equations. Rotation changes the picture subtly. It creates an ergosphere, a region outside the event horizon where space and time are dragged around with the black hole's spin. In that ergosphere, it's theoretically possible for particles or radiation to gain energy from the black hole's rotation. This is known as the Penrose process, meaning a spinning black hole can, under the right circumstances, have some of its energy extracted. This rotation is also tied to those massive jets we'll discuss soon. The spin helps twist magnetic fields and launch particles outward. Rotating black holes have a slightly different singularity structure too. Instead of a point, a rotating black hole's singularity could form a tiny ring. If one were fanciful, one might imagine that passing through the center of that ring singularity in a purely hypothetical scenario might lead to another patch of space-time or another universe, though in reality any such passage would be prevented by the extreme forces and radiation in a real collapse. Astrophysical black holes can also carry electric charge, but in practice they likely don't hold much charge because they attract opposite charges from their surroundings and quickly neutralize. So, mass, spin, and very minimally charge define a real black hole's properties. To better grasp a black hole, imagine the fabric of space as a stretched rubber sheet. A small object, like a planet or a star, makes a dent in that sheet, a gravity well. But a black hole is like a deep puncture. Instead of just a dent, it's a bottomless pit in the fabric, a well so deep that anything that falls in cannot climb out. Another analogy is to think of escape velocity, the speed needed to break free of an object's gravity. For Earth, rockets must go about 11 kilometers per second to escape into space. For a neutron star, an extremely dense stellar remnant, escape speed is a significant fraction of light speed. But for a black hole, at the event horizon, the escape speed equals the speed of light. And since nothing can go faster than light, nothing that gets that close can escape the hole's gravity. How do such strange objects come into being? The story of a black hole often begins with a star much more massive than our sun. Stars are radiant spheres of plasma, balancing two titanic forces: the outward pressure from nuclear fusion in their core, and the inward pull of their own gravity. For most of a star's life, these forces are in equilibrium. But when a very massive star exhausts its nuclear fuel, fusion dwindles and the outward pressure falters. Gravity, ever present, suddenly overwhelms the star's support. In a massive star's final moments, it may explode in a brilliant supernova, shedding its outer layers into space. But the core, no longer held up by fusion, collapses under gravity's relentless pull. If the core's mass is above a certain threshold, around a few times the mass of our sun, nothing can halt the collapse. At that moment, the core is crushed beyond even the density of atomic nuclei, and a black hole is born. This newborn black hole might have, say, a mass 10 times that of the sun, but it is packed into a space only a few tens of kilometers across, a truly tiny radius compared to any star. The boundary of this black hole, its event horizon, would perhaps be the size of a small city or smaller. Imagine something 10 times heavier than the sun, crammed into an area you could drive across in an hour. The gravity near such a compact mass is intense to an extreme degree. This is a stellar mass black hole, formed from the death of a single massive star. Not all stars create black holes when they die. Only the most massive ones do. Stars with more modest mass, like our sun, will end their lives differently, the Sun will shed its outer layers and leave behind a white dwarf, not nearly dense enough to be a black hole. But in the universe's stellar nurseries and graveyards, the heavyweights, stars perhaps 20 or 30 times the Sun's mass or more, live fast, die young, and in death can give birth to these dark remnants. Stellar mass black holes are not rare in a large galaxy. It's estimated that the Milky Way alone might contain tens of millions of these hidden black holes, left over from generations of massive stars. They are scattered throughout the galactic disk and halo, mostly unseen unless they interact with something. Occasionally one might betray itself by gravitationally lensing a background star, causing a brief brightening known as a micro-lensing event, or by emitting X-rays as it consumes stray matter. Black holes don't remain static after formation either. They can grow. One way they grow is by accreting matter, that is, pulling in gas, dust, or any other nearby material that strays too close. When a black hole passes through a cloud of gas or has a companion star orbiting it, it can slowly feast, drawing material inward. Another way black holes grow is through mergers. If two black holes happen to meet, perhaps after a long spiral dance in a binary system, they will coalesce into a larger black hole. In fact, much of what we have learned about black holes recently comes from detecting the powerful but invisible tremors of such collisions, gravitational waves, which are ripples in space-time itself that spread outward like the faint ringing of a cosmic bell when massive objects like black holes collide. In September 2015, scientists using the LIGO detector on Earth first observed these ripples directly. They heard a faint chirp, the literal sound of two distant black holes merging into one, converting a portion of their mass into a fleeting vibration of the universe. That moment was a triumph for physics and astronomy. A gentle whisper from billions of light years away told us that black holes not only exist, but they bump into each other and merge, and we can hear it happen. Since then, many such chirps have been recorded, each telling the story of black holes dancing and uniting. It is as if we developed a new sense, the ability to feel the universe's fabric quiver when black holes do their cosmic dance. Through processes of accretion and merger, black holes can become more massive over time, like cosmic snowballs growing as they roll. But regardless of how large they grow, they retain the same basic structure, an event horizon enveloping a hidden singularity, and an influence that extends outward, tugging on the fabric of space. Ultimately, a black hole is the universe distilled to its extremes, a region of pure gravity, simple in its definition, yet capable of immensely complex effects on the world around it. Not all black holes are the same. They come in a range of sizes and masses. The ones born from dying stars, as we discussed, are stellar mass black holes. They might weigh a few times up to perhaps dozens of times the mass of our Sun. These are scattered throughout galaxies, often invisible unless they reveal themselves by interacting with other matter. In our own Milky Way galaxy, astronomers have found several such black holes indirectly. For instance, by observing stars that seem to orbit an unseen massive companion, or by detecting X-ray flares from gas being devoured by a hidden object. Each of these cases hints at a small black hole, a remnant of a long-gone massive star. But at the opposite end of the spectrum, there exist supermassive black holes. These giants lurk in the centers of galaxies. While a stellar black hole might be a few kilometers across, a supermassive black hole can be as large as the entire orbit of Earth around the Sun, or even bigger. Their masses range from hundreds of thousands to billions of suns. It's hard to fathom something that massive. Imagine packing millions or billions of stars into a single black hole. One famous example is the black hole at the heart of the galaxy M87, which was the first black hole ever imaged directly by the Event Horizon Telescope. That black hole weighs about 6.5 billion times the Sun's mass. The image released showed a fuzzy ring of light, the glowing accretion disk around a dark shadow, which is the black hole's silhouette. Another even larger monster is the quasar TON 600, which harbours an ultramassive black hole estimated to be on the order of 60 to 66 billion solar masses. A black hole that massive would have a Schwarzschild radius, event horizon size, of roughly 1,300 astronomical units, meaning its surface would be over 1,000 times wider than Pluto's orbit. It defies imagination how such a behemoth formed. It likely involved many mergers and perhaps very early universe conditions that allowed rapid feeding. These ultramassive black holes are extreme outliers, but they demonstrate that there might not be a strict upper limit, or at least an extremely high one, to how large a black hole can grow by consuming matter and merging. Every large galaxy is believed to host a supermassive black hole at its centre. Our own galaxy, the Milky Way, has a central black hole called Sagittarius A. It's about 4 million times the mass of the Sun, relatively small as supermassive black holes go, but still enormously heavy by any other standard. Normally, it's quiet, not consuming much matter at this moment, so it's not very luminous. But we know it's there from the way stars in the galactic centre whirl around an invisible mass. Over the 1990s and 2000s, astronomers patiently tracked the motions of these central stars. They observed stars moving in incredibly fast, tight orbits, some taking only a decade or two to complete a circuit. One star, known as S2, was seen whipping around an unseen focus at a staggering speed of thousands of kilometers per second, following an elliptical orbit that took it just 17 light hours from the center, about 4 times the distance from our Sun to Neptune, before slingshotting back out. By mapping these orbits, scientists deduced that about 4 million solar masses had to be packed into a region no larger than our solar system. Nothing known could be so massive and compact except a black hole. These observations, a crowning achievement that earned a Nobel Prize in 2020, provided ironclad evidence of a supermassive black hole at our galaxy's heart. It's like watching planets orbit an invisible sun, only that sun is a gravitational pit. Occasionally, when a stray cloud of gas wanders too close, Sagittarius A will produce a flare as the gas is ripped apart and heated, offering a glimpse of the sleeping giant stirring. How do supermassive black holes form? That remains an open and intriguing question. They exist even in very distant, ancient galaxies, which means they had to form relatively quickly in the universe's early years. Some theories suggest they grew from smaller seed black holes, perhaps the remnants of the first generation of stars, or dense stellar clusters, that merged and accreted matter over billions of years. Others propose more radical beginnings, like the direct collapse of enormous primordial gas clouds in the young universe, forming a black hole thousands or hundreds of thousands of times the Sun's mass in one go, without a supernova. However they started, once a supermassive black hole is in place, it can keep growing by eating gas and by merging with other black holes when galaxies collide. Between the stellar mass and supermassive scales lies a somewhat enigmatic category: intermediate mass black holes. These would be black holes heavier than any single star, say hundreds or tens of thousands of solar masses, but much smaller than the monsters in galactic cores. For a long time, these were purely hypothetical. We hadn't clearly seen them, but evidence has been mounting that they do exist. For instance, in dense star clusters or small dwarf galaxies, signs of mid-sized black holes have been observed, unusual X-ray sources, or the behavior of stars indicating a hidden mass of, say, a few thousand suns. One example is a black hole of a few thousand solar masses that astronomers believe resides in a star cluster in the galaxy M82, detected by intense X-ray emissions. Gravitational waves have given us direct evidence too. One event detected by LIGO showed two black holes merging to form a final black hole of about 140 solar masses, essentially witnessing the birth of an intermediate black hole from smaller ones. The existence of these intermediate black holes might fill in the gap of how you go from a star-sized hole to a supermassive one. They could be the stepping stones that merge or accrete to become the giant nuclei of galaxies. There's also speculation about primordial black holes, a very different kind of black hole that might have formed not from stars, but from the high energy, high density conditions just after the Big Bang. In those first moments of the universe, tiny fluctuations in density could, in theory, have been dense enough in places to collapse into black holes of various sizes. These could have had a wide range of masses, from microscopic black holes weighing less than a mountain, to perhaps the mass of a planet or more. Primordial black holes remain hypothetical. We haven't found definitive evidence for them. If very small ones formed, many might have evaporated by now through Hawking radiation. Heavier ones might still be around, as part of the mysterious dark matter that makes up much of the universe's mass. If a significant number of primordial black holes had formed, they might contribute to the dark matter we infer via gravity, the unseen mass in galaxies. But so far there is no conclusive evidence that they do. It remains a question modern astronomy is keen to answer. It's an intriguing idea. Scattered through the cosmos, there could be ancient black holes older than any star, relics of the universe's birth itself, quietly roaming interstellar space virtually undetectable. From the gargantuan centers of galaxies to the tiny speculations of primordial remnants, black holes present themselves as a family of phenomena, bridging a vast range of scales. They all share the defining feature of an event horizon and an interior we cannot see. Whether it's a few kilometers across or wider than our solar system, a black hole bends the fabric of space the same way, just differing in scope. Knowing this, as we continue our voyage, we can picture a cosmic landscape dotted with these curious objects. Some are the ashes of dead stars, others the engines in galactic hearts, and perhaps some are ancient fossils of creation itself. Each one, big or small, connects to the same mysteries of gravity and time. Black holes themselves may be dark, but the surroundings of an active black hole can shine brilliantly. When a black hole has a supply of fuel, gas, dust, or even an unfortunate star that wanders too close, that material doesn't usually fall straight in. Instead, it swirls around, forming an accretion disk. Picture water spiraling down a drain, forming a whirlpool. Similarly, matter drawn in by a black hole's gravity often forms a flattened disk orbiting the black hole, like a whirlpool of glowing gas. As the gas in the disk spirals inward, it rubs against itself, causing friction and heating up. The closer it is to the black hole, the faster it moves and the hotter it gets, often reaching millions of degrees. At such extreme temperatures, the disk emits a tremendous amount of radiation, especially high-energy X-rays. This is why black holes are paradoxically some of the brightest objects in the sky when actively feeding. They themselves emit no light, but their dining habits light up their vicinity. One of the earliest strong hints that black holes truly exist came from observing these X-ray emissions. In the late 1960s and early 1970s, astronomers discovered a powerful X-ray source in the constellation Cygnus, dubbed Cygnus X1. It was invisible in ordinary light, but the X-rays were coming from a region where a visible star was found to be orbiting an unseen companion. The data suggested the companion was a heavy, compact object pulling gas from the visible star. The gas spiraled in and heated up, producing X-rays, just as an accreting black hole would. Cygnus X1 became the first widely accepted black hole candidate. Its discovery turned black holes from theory into tangible reality. Since then, many other X-ray binary systems have been found, where a stellar mass black hole announces its presence by the X-rays from its accretion disk. These systems often vary in brightness as the black hole gulps down matter in fits and starts, almost like a cosmic heartbeat. If you were safely distant, watching an accretion disk around a black hole, you would see a luminous, often bluish or white-hot disk encircling a dark center. The light from the disk is distorted by the black hole's gravity. You might notice a strange image, a somewhat halo-like shape, because gravity bends the path of light coming from the far side of the disk. You might see a warped glow above and below the black hole. That's actually the far side of the disk, whose light has been bent around. And one side of the disk may look brighter than the other. The disk's material is orbiting at tremendous speeds, approaching the speed of light in the inner regions. Due to the Doppler effect, relativistic beaming, the side of the disk that is rotating toward us will appear a bit brighter and bluer, while the side moving away appears dimmer and redder. So the disk could look asymmetric in brightness, a subtle but fascinating detail that confirms relativity is at work. Accretion disks can be found around black holes of all sizes, from stellar mass ones to supermassive ones. In binary star systems, a stellar black hole can pull gas from a companion star into a disk, creating flickering X-ray sources we can detect. Around a supermassive black hole in a galaxy's core, the accretion disk can be vast and extremely luminous. This is what we observe as quasars, which are essentially the blazing accretion disks of distant supermassive black holes actively consuming material. Quasars shine so brightly that they can outshine the entire galaxy they reside in, visible across billions of light years. It's humbling to realize that this immense energy comes from matter on a cosmic merry-go-round, heating up as it falls into darkness. Now, as spectacular as accretion disks are, there is another phenomenon associated with black holes that is equally astonishing: jets. Under certain conditions, a feeding black hole can produce narrow beams of particles and energy that shoot out from the regions near the black hole's poles. These jets travel at speeds close to the speed of light and can extend far into space. For supermassive black holes, a jet can stab out of a galaxy's core and reach well beyond the galaxy itself, like a cosmic flashlight piercing the darkness. How do these jets form? It's a complex dance of gravity, magnetic fields, and rotation. Many black holes, especially big ones, spin rapidly. A rotating black hole can twist up magnetic field lines in the swirling disk of plasma around it. Like a twirling spaghetti fork, these magnetic lines can wind tighter and tighter until they snap and reconnect, flinging charged particles outward along the rotational axis, forming twin jets that blast away above and below the disk. If you've ever seen a photo of the galaxy M87, you might recall an image with a hazy glow of the galaxy and a long, needle-like blue beam emanating from its center. That is a jet from M87's central black hole, the same black hole whose shadow was imaged. Up close, the jet is an awe-inspiring stream of high-energy particles. In visible light, it appears bluish due to synchrotron radiation from electrons spiraling along magnetic fields. These jets carry tremendous energy and can extend astonishing distances. The sheer scale of the jets is mind-boggling. They can reach lengths of hundreds of thousands of light-years in some cases, far beyond their host galaxy's visible edge. The jet from M87's black hole, for example, is observed to stretch at least 5,000 light-years from the galaxy's core, shining in radio and optical wavelengths. Imagine a stream of matter and energy so long that even a beam of light would take thousands of years to traverse from end to end. Yet to the black hole, launching such a jet is a byproduct of its feast. These jets can influence their environment dramatically by heating and blowing away gas in the galaxy. They can prevent some of that gas from cooling and forming new stars. In this way, a black hole's activity can regulate the life of an entire galaxy. It's a beautiful irony that something known for being a one-way trap can, through its jets and radiation from its disk, affect regions of space millions of times larger than itself. From a safe vantage point, one might marvel at the sight. A brilliant disk encircling darkness, and from the poles of that dark region, beams of light or particles extending far out, perhaps invisible except to specialized instruments. The near side of a jet, pointed somewhat toward us, often appears brighter due to its relativistic motion beaming its light our way, while the opposite jet, directed away, is fainter or sometimes unseen. To our eyes, the black hole itself remains a silhouette, but its presence is betrayed by the frenetic energy around it. It's remarkable that something known for being so dark can create such brilliant fireworks in its vicinity. In a sense, the accretion disk and jets are the black hole's way of interacting with the rest of the universe. A cosmic conversation of light and matter. Through them, black holes can influence their surroundings on huge scales, from the behavior of nearby stars to the evolution of entire galaxies. They can be quiet, stealthy eaters, or spectacular, messy diners flinging out energy. As we watch this process in our mind's eye, we appreciate that black holes are not merely the endpoints of stars. They are dynamic players in the cosmos, sometimes violent, sometimes quiescent, but always fascinating. Now that we have an understanding of a black hole's anatomy and behavior, let's conduct a thought experiment. Imagine a brave, or perhaps foolhardy, astronaut deciding to venture towards a black hole to see up close what happens. What would it actually feel like to approach and even cross the event horizon? The answer depends on the black hole's size, and it leads us into some truly strange aspects of physics, time dilation, and what's poetically called spaghettification. First, consider a relatively small black hole, the kind formed from a star. As our astronaut draws closer, the gravitational pull on their feet, closer to the black hole, is noticeably stronger than the pull on their head, farther from the black hole. This difference in gravity across their body is called a tidal force, the same kind of force that raises tides on Earth. The moon pulls a bit harder on the side of Earth closer to it than on the far side, stretching the oceans. In the vicinity of a small black hole, these tidal forces become extreme. They would begin to stretch the astronaut lengthwise and compress them sideways. In grisly terms, physics predicts an object, or unfortunate person, would be spaghettified, stretched into a long, thin strand. The closer to the black hole, the stronger this stretching force becomes, until it overwhelms molecular bonds and literally pulls matter apart. For a stellar mass black hole, this fatal stretching would occur well before the astronaut even reaches the event horizon. They would be torn apart and reduced to a stream of atoms falling inward, long before crossing into the black hole's darkness. However, imagine instead a supermassive black hole, like the ones in galactic centers. Such a black hole could be millions of times more massive, which means its event horizon is much farther out from the central singularity. The tidal forces at the horizon could be relatively gentle. Our hypothetical astronaut might actually cross the event horizon of a supermassive black hole without immediate destruction, because the gradient of gravity, difference in pull between head and feet, at that scale is not so abrupt at the horizon. They might feel nothing particularly extraordinary at the moment of passing the point of no return. Only later, as they journey further inward, would the tidal forces ramp up to lethal levels, ultimately crushing and stretching everything as the singularity is approached. So, for a sufficiently large black hole, one could at least imagine surviving the horizon crossing itself physically intact, though of course they could never report back, being trapped beyond communication. Now comes the truly mind-bending part. Time. Einstein's relativity tells us that time is not absolute. It flows differently depending on gravity and motion. Near a black hole, gravity is so strong that time itself is significantly slowed down relative to far away. If our astronaut hovers just outside the event horizon, say they have powerful rockets to keep from falling in, or more realistically, they orbit just outside the horizon, to an outside observer far away, the astronaut's movements would appear to slow and almost freeze as they approach the horizon. For instance, if they tried to send a series of light signals, like flashing a flashlight, outward, each successive flash would be received with increasing delays and redder, lower energy. From the distant observer's view, time at the astronaut's location seems to crawl. In fact, as the astronaut gets infinitesimally close to the horizon, they would asymptotically fade and never quite appear to cross it. Their image would become dimmer and more redshifted, shifted to longer, redder wavelengths, and eventually slip out of detectability. In a literal sense, to the external world, it's as if the astronaut gets stuck right at the edge, frozen in time, though really the image is just extremely slow and dim. From the astronaut's own perspective, however, nothing so strange happens to their personal time. Their heart beats, their thoughts flow, and their clock ticks normally for them. They head straight toward the black hole and pass the event horizon in a finite amount of their own time, without fanfare. If they look back toward the outside universe as they go in, they might see something extraordinary. The universe's clock running fast. Light from the outside world would be blue shifted, compressed to higher energy, because from their point of view, the outside is in a shallower gravity well and time is speeding up out there. If they could somehow survive long enough just inside the horizon and look out, they might see the entire future of the universe play out in a kind of fast forward. In a sense, falling into a black hole could be a one-way trip to the far future. You might witness the fate of the universe in a compressed span of your own time, though you can't come back to tell the tale. To give a less extreme illustration, suppose our astronaut decided not to dive in, but to orbit a black hole at a safe distance where gravity is strong but not immediately deadly. Time would run slower for them relative to Earth. If they orbited for what they felt was 1 year, perhaps a few years might pass on Earth, depending on how close they were to the horizon. This is like the scenario in the movie Interstellar, where a planet near a black hole experiences 1 hour while 7 years pass elsewhere. an exaggerated but rooted in truth example of gravitational time dilation. Before our astronaut succumbs to the black hole, they might notice other odd visual effects. If they could look out from near the black hole, the star field around might appear distorted. Light from stars behind the black hole can be bent around, so they might see a halo of light, essentially the photon sphere, where light can orbit the black hole. There might be multiple rings of light, which are really multiple images of the distant universe, each ring corresponding to light that orbited the black hole 1, 2, or more times before escaping to the astronaut's eyes. The whole sky would seem to warp and wrap around the black hole's darkness. For example, they might see a duplicate image of the galaxy behind the black hole, appearing as a smeared circle. The accretion disk, if present, would also appear odd. Gravity would make the underside of the disk visible above the black hole as a secondary image. It would be like being in a funhouse hall of mirrors, except the mirrors are the warps of space-time itself. All directions around might start to look like down, as gravity's pull dominates perspective. Meanwhile, from the point of view of us watching from far away, the astronaut would never be seen to actually fall through the horizon. We'd see them slow down and fade, their light signals coming ever more slowly and faintly. In practice, after a while, we wouldn't detect them at all. But not because they suddenly vanished at a moment, rather because eventually their emitted light becomes too red, low energy, and too spread out in time to be noticeable. The outside world effectively loses contact. So, falling into a black hole involves two main hazards and wonders: tidal forces that can rip you apart, unless it's a supermassive black hole, which gives you a temporary pass until deeper in, and gravitational time dilation that alters the flow of time relative to the outside world. It is both violent and awe-inspiring. On one hand, it's a descent into ultimate darkness with no return. On the other, it's a journey through a warped realm where the normal order of past, present, and future is distorted. For all its destructive potential, this thought experiment of falling in gives us a taste of the weirdness near a black hole, where space twists and time slows, in a final silent cascade into the unknown. For our purposes, we won't send our astronaut all the way in to oblivion. Instead, let's hover at a safe distance and observe these effects from outside, appreciating how nature behaves at the edge of a black hole. By doing so, we learn not just about black holes, but also about the elasticity of time and the limits of our physical understanding. Up to now, we've been considering black holes as nearly eternal traps. Once something falls in, it's gone forever, and the black hole only grows or stays the same. For a long time, even scientists believed black holes were truly black and could only gain mass, never lose it. But in the 1970s, a groundbreaking idea from physicist Stephen Hawking changed that perception. Hawking proposed that black holes aren't completely black after all. They can emit a very faint glow due to quantum effects near the event horizon. This theoretical emission, now known as Hawking radiation, arises from the strange properties of the quantum vacuum. The concept is subtle and fascinating. In the vacuum of space, particles and their antiparticles constantly pop into existence in pairs, only to annihilate and disappear an instant later. This is allowed by quantum uncertainty, and it's happening all the time, everywhere, even in empty space. Near a black hole's event horizon, imagine such a pair of virtual particles forming. Normally, they would destroy each other almost immediately. But if this happens right at the edge, it's possible for one of the pair to fall into the black hole, while the other escapes before they can recombine. The one that escapes becomes a real particle, carrying away energy that was effectively taken from the black hole's gravitational field. To an outside observer, it's as if the black hole emitted that particle. Meanwhile, to balance the books, the particle that fell in is like it had negative energy from the perspective of the black hole, which reduces the black hole's mass slightly. In essence, the black hole loses a tiny bit of its mass every time it emits one of these Hawking radiation particles. For any astrophysical black hole of substantial size, this radiation is incredibly feeble. The temperature associated with Hawking radiation is inversely related to the black hole's mass. For a black hole with the mass of our Sun, Hawking's formula gives a temperature on the order of 10^8 kelvins, far colder than the 2.7 K cosmic microwave background, the afterglow of the Big Bang. That means such a black hole is actually cooler than the surrounding universe, so it will absorb more radiation from the universe than it emits via Hawking radiation, effectively still gaining mass overall right now. Only once the universe expands and cools far enough, in many billions of years, would the Hawking emission dominate and the black hole begin to evaporate faster than it gains energy from the faint ambient light. The principle implies a spectacular destiny. Given enough time, truly mind-boggling amounts of time, a black hole will evaporate completely. The smaller the black hole, the hotter it is, and the faster it evaporates. If you had a tiny black hole, say one with the mass of a mountain, it would evaporate in a flash of energetic radiation in a tiny fraction of a second. A black hole of a few billion tons, the mass of a big asteroid, might last only a moment, producing a burst of high-energy gamma rays. In contrast, a black hole of a few solar masses would take on the order of 10 or 67 years to evaporate, a number vastly larger than the current age of the universe, which is 1.38 plus 10 years, about 13.8 billion. For the supermassive black holes weighing billions of suns, their lifetimes due to Hawking radiation stretch truly beyond comprehension, around 10 or 100 years or more. One might call these timescales eternity for all practical human purposes. Yet in the grand perspective of cosmology, even 10 or 100 years is a finite time that could mark an end for these giants. What does a black hole's evaporation look like? In the initial eons, as it slowly radiates, the loss of mass is imperceptible. But as the black hole shrinks, its temperature rises, meaning it radiates faster. In the final phase, when a black hole becomes very small, Hawking radiation would become intense, and the black hole would release a burst of high-energy light and particles, essentially exploding in a final flash. For a stellar mass black hole, this endpoint is so far in the future that by then, all stars will have long since died out, and even galaxies may have dispersed. It's poetic in a way. Black holes, which come from star death, outlive the stars, and even the galaxies, only to eventually wink out themselves, returning their stolen energy back to the universe. Have we observed Hawking radiation directly? Unfortunately, no. It's far too weak for any black hole we can observe. However, scientists have searched for signs of small primordial black holes evaporating in the present era, hypothesizing that if some tiny black holes were formed in the early universe, they might be ending their lives now and could produce flashes of gamma rays. So far, no definitive such flashes have been seen, which places limits on how many primordial black holes could be out there. The idea of Hawking radiation also brought about a deep puzzle in physics called the black hole information paradox. If black holes eventually evaporate completely, what happens to the information about all the matter that fell into them? In quantum physics, information, in principle, is never destroyed. The exact detailed properties of a system might be scrambled or hidden, but they're not lost from the universe. But if a black hole disappears, and all it leaves is Hawking radiation, that, according to Hawking's initial argument, is featureless thermal noise, it would seem the detailed information of whatever fell in is lost forever. This paradox has led to intense theoretical debates and insights. Many physicists now suspect that the information does somehow get imprinted in the Hawking radiation in a highly encrypted form, or that perhaps the information is stored in correlations on the event horizon and released slowly, meaning that black holes aren't violating quantum laws after all. One intriguing proposal to resolve this paradox is that information is not lost at all, but is somehow encoded on the event horizon itself. This idea contributed to what's known as the holographic principle, the notion that all the information contained in a volume of space, like the interior of a black hole, can be represented as a hologram, a two-dimensional pattern on the boundary of that space, the black hole's horizon. In other words, as stuff falls into a black hole, the horizon's state changes in a way that preserves the information about that stuff, effectively storing a highly encrypted record of it on the black hole's surface area. Then, as Hawking radiation is emitted from the vicinity of the horizon, it can, in principle, carry away that information, albeit in a terribly scrambled form. It's as if the black hole's surface is a cosmic hard drive with ultimate encryption, slowly leaking its data back out via subtle quantum whispers. This principle, if correct, wouldn't violate thermodynamics or quantum mechanics. The information isn't destroyed, only transformed in extreme ways. The holographic idea has found support in certain advanced theories like string theory, and it has reshaped how physicists think about space, gravity, and information. For our story, it reinforces a poetic notion. The event horizon is not just a point of no return, but also a mysterious ledger where the universe keeps track of everything that falls in, ensuring that in some form, information, the memories of infalling matter, is conserved, even in the face of apparent oblivion. For our gentle voyage, the specifics of resolving the information paradox need not detain us further. What's important is the grand implication. Black holes are not the eternal prisons we once thought. Given eons upon eons, they will slowly give back to the universe whatever they have taken in, though in a highly transformed manner. This means that in the far future, black holes will not last forever as silent sentinels. They too will fade. Hawking's revelation adds an unexpected chapter to the life story of a black hole. After a long life of eating and growing, there is an even longer twilight of shrinking and evaporating. Black holes have a life cycle of their own, stretched across unimaginable durations. The once one-way nature of a black hole is thus slightly softened. Over inconceivable spans, it returns its borrowed energy to the universe, reminding us that even these dark giants are part of the cosmic cycle of matter and energy. Picture, if you will, a lone black hole in the far future, with no more stars or gas to consume. It's slowly evaporating, glowing ever so faintly with a ghostly light of its Hawking radiation. As it gets smaller, the glow increases in temperature and intensity, from a cold whisper to perhaps a warm glow in its final moments. Then, In a silent burst, it releases its last energy and is gone, leaving nothing but a faint mist of particles. The night that was once punctuated by occasional black hole flares finally goes completely dark. This scenario, the final evaporation of the last black hole, is a key element in the vision of how the universe might end, which we'll explore soon. The discovery that black holes have entropy and emit radiation forged a profound link between gravity and thermodynamics. In physics, thermodynamics is the study of heat, energy, and entropy, where entropy is a measure of disorder or randomness. There is a famous principle called the second law of thermodynamics, which, simply put, states that in any closed system, entropy tends to increase over time. Entropy can be thought of as the degree of disorder. Eggs break, but don't spontaneously unbreak. A drop of ink disperses in water, but never gathers back together. These are entropy increasing, giving a direction to time, an arrow of time. For a while, people wondered how black holes fit with thermodynamics. If you throw something with a lot of entropy, say a hot gas, into a black hole, from the outside it seems like you've made that entropy disappear, potentially decreasing the universe's entropy, which would violate the second law. Jacob Bekenstein was one of the first to argue in the 1970s that a black hole must have an entropy proportional to its event horizon area, and that when something falls in, the increase in the black hole's entropy more than compensates for the loss of entropy outside. Hawking's calculation of black hole radiation solidified this idea, showing that black holes indeed behave like thermodynamic objects, with a well-defined temperature and entropy. A black hole's entropy is stupendously large. For example, the entropy associated with a black hole of one solar mass is on the order of 1077 bits of information, an almost unfathomable number. By comparison, the Sun's entropy, due to its hot gas, is about 10 to 58 bits, vastly lower. Essentially, a black hole packs an enormous amount of disorder. Dropping something into a black hole increases the black hole's surface area, and thus its entropy, by an amount that exceeds the entropy that object had outside. So the total entropy still goes up, and the second law holds true. The black hole, in a sense, is the ultimate entropy sink, a place where information and order go in, and an increase in entropy, mostly hidden behind the horizon, is what we tally. This perspective has a profound implication for the arrow of time. We experience time's flow in one direction, the direction of increasing entropy, from past, lower entropy, to future, higher entropy. Black holes, with their one-way nature, are like entropy amplifiers. Once information goes in, it doesn't come out in any organized way. It's effectively lost to us, which corresponds to a big leap in entropy. They are a thermodynamic arrow pointing forward in time. But interestingly, if black holes eventually evaporate and return their entropy to the wider universe, then in the very end, even those hidden entropy stores are released. The second law is obeyed at every step. Entropy never decreases. It just sometimes hides behind horizons for a while. When the black hole is gone, that entropy, in the form of Hawking radiation's entropy, is back out in the universe. This tying together of gravity and entropy leads to some remarkable insights. One is that our universe might itself have a kind of horizon, the cosmological horizon due to expansion, and a maximum entropy associated with it, hinting that perhaps even the universe as a whole can be described in holographic terms. But more concretely for our journey, it tells us that black holes, those seemingly simple holes in space, are deeply woven into the story of cosmic evolution and destiny. They are reservoirs of entropy, that will play out their role as the universe ages. On a philosophical level, thinking about entropy and information in the context of black holes invites reflection on the nature of loss and persistence. When something falls into a black hole, is its essence truly lost? Physics leans toward no. That information still exists, just in scrambled form. It suggests a kind of cosmic resilience of information. The universe keeps an accounting, even if beyond our reach. We might find a strange comfort in that. Even in destruction, there's a sort of order. The total information content is conserved. In a more poetic sense, one could say that nothing absolutely disappears without a trace. The black hole's horizon records it, and the Hawking radiation later shares it, albeit in a way no normal being could decipher. In everyday life, we know that some processes are irreversible. You can't unburn paper or unmix cream from coffee. Black holes epitomize irreversibility on a cosmic scale. Yet, the underlying laws hint at reversibility when all is taken into account. It's a reminder of how reality can be very different from how we perceive it. We see one arrow of time, but on the fundamental level, there might be a balance sheet that always evens out. As we continue, we'll carry forward the sense that black holes connect to the arrow of time and the fate of cosmic order. They teach us that one-way processes in the universe, like things falling in and seemingly never coming back out, are part of a grander picture that still obeys cosmic rules. The second law of thermodynamics, with entropy always increasing, will be a key guide when we soon ponder the possible final end states of the universe. Before we pull all the way back to the fate of the cosmos, let's consider something closer to home: how we humans explore these mysteries. Black holes present both a tantalizing target for exploration and a formidable challenge. Because nothing can escape from within the event horizon, we can never retrieve a sample or directly see inside. But that hasn't stopped us from probing their secrets from afar. We've already begun to observe black holes in ingenious ways. The Event Horizon Telescope, EHT, which produced that famous image of a black hole's shadow in 2019, is being upgraded to capture even sharper images and perhaps even movies of the swirling plasma around black hole horizons. Future observatories will observe black holes in new wavelengths and with better resolution, revealing more about their disks and jets. Gravitational wave detectors on Earth, like LIGO and Virgo, and planned space-based detectors, like LISA, are poised to hear the mergers of black holes of various sizes, even the colossal mergers of supermassive black holes in distant galaxies. Each gravitational wave signal is like hearing a faint cosmic melody that tells us about the masses and spins of black holes colliding, giving us insight into how black holes pair up and merge over time. One day, far in the future, we might even consider sending probes closer to a black hole. It's a daunting prospect with current technology, but conceptually not impossible. A spacecraft could orbit a black hole at a safe distance and study the environment, measuring magnetic fields, detecting high-energy particles, observing the gravitational effects up close. Of course, the journey to the nearest black hole, there is likely one a few thousand light-years away, would take an extraordinary amount of time with conventional propulsion. But who knows what future advancements may bring? Perhaps in a distant future, an advanced civilization, human or otherwise, could dispatch a probe to orbit Sagittarius A, the Milky Way's central black hole, and gather direct data. Such a probe might exploit the intense gravity to perform experiments on general relativity. For instance, precisely measuring how time flows in such a strong gravitational field, or mapping the shape of space-time near the event horizon to test Einstein's theory in extreme conditions. There's also the tantalizing idea of using black holes as tools. Some futuristic concepts involve creating or capturing a small black hole to use as an energy source. If you had a tiny black hole, its Hawking radiation could be a potent power source. Hawking himself mused about this in a playful way. Another idea is using rotating black holes for energy extraction. As mentioned, if something enters the ergosphere, it can come out with more energy, stolen from the black hole's rotation. Science fiction has imagined machines or civilizations leveraging this process. While these ideas are far beyond current capabilities and understanding, they show how black holes spark our creativity, turning from scary devourers to potential wells of energy or even gateways. Wormholes, the hypothetical tunnels through space-time, are another aspect tied to black hole exploration in imagination. If a stable wormhole could exist, a big if, it might allow near instantaneous travel between distant points in space or even time travel. While purely speculative, wormholes have become staples in science fiction. From Contact, where an alien-made wormhole transports a human across the galaxy, to Interstellar, featuring a naturally occurring wormhole near Saturn that enables journeys to another galaxy. These stories, while fictional, are built on the real physics concept we discussed, and they demonstrate our desire to find shortcuts in the vast cosmic distances. For now, our exploration of black holes is done with telescopes and detectors, not starships. But even that is yielding rich rewards. We are finding more black holes by their subtle gravitational effects. For example, monitoring the light of distant stars to catch the slight brightening when a compact object passes in front, gravitational microlensing, can reveal hidden black holes drifting through the galaxy. We're seeing stars at the centers of galaxies being shredded when they venture too close to the central black hole, a phenomenon called tidal disruption events, which produce flares of light. Each observation is like a postcard from the edge of a black hole, adding pieces to the puzzle. Our journey of understanding black holes is still in its early stages. Not long ago, they were purely theoretical. Now we have images of one and sounds of others merging. Perhaps one day, in the far future, with technologies we can scarcely imagine, we'll venture close to a black hole and observe its mysteries directly, or even use them for ambitious purposes. Until then, we explore with our minds and our ever-improving instruments, peeling back the layers of mystery. It's a testament to human curiosity that we've come this far. From Michelle's dark star musings to photographing a black hole's shadow, each generation peeks a little further into the dark. In the cosmic ocean of knowledge, black holes were once like sea monsters on ancient maps. Here be dragons, the unknown. Now we've sailed into that territory. There are still dragons, mysteries, to be sure. Singularities, quantum gravity, wormholes. But we are charting the waters with steady progress. And as we do, we're not only learning about gravity and space, but also pushing the limits of technology and our own imagination. In our journey so far, we've dealt with the physics of black holes and even the speculative idea of wormholes. Let's now take a moment to gather the philosophical and existential threads woven throughout our discussion to prepare our minds for contemplating the end of time itself. Each layer of reflection, scientific, philosophical, emotional, enriches our understanding, making this cosmic narrative not just an external journey, but an inner one as well. At this juncture, it's helpful to pause and reflect on what all these cosmic phenomena mean in a broader sense. We've wandered from the tangible into the speculative, and from the physical into the philosophical. Black holes, white holes, wormholes, these stir up fundamental questions about time, existence, and the meaning of an end. Time is a thread running through our entire journey. We've seen time behave in unusual ways near black holes, slowing down and potentially offering a glimpse into the distant future. But what exactly is time? We experience it as a flow of moments, one after another, like frames of a never-ending film reel. Yet physics tells us time is interwoven with space, forming the four-dimensional fabric of space-time, and that it had, as far as we know, a beginning 13.8 billion years ago with the Big Bang. Could it have an end? If the universe reaches a state where nothing happens anymore, does time still have meaning? These are almost metaphysical questions. The end of time could mean a literal halt, as in some theoretical cosmologies, or it could mean time simply becomes irrelevant because there's no change to mark it. Philosophers and scientists have pondered the nature of time for centuries. Some liken all moments of time to a landscape. The past, present, and future all equally existing in a block universe, with us conscious beings just moving along it. Others propose that time might be an emergent property that could fade if the universe becomes too simple. From our earthly perspective, time is tied to cycles, days, seasons, lives. But on cosmic scales, time can stretch and bend in ways that defy our intuition. Our journey to the black hole's edge showed that even the sequence of events can depend on where you are and how you move. Then there's the meaning of an ending. In human experience, endings often feel significant. The end of a story, the end of a life, the end of an era. We naturally project that significance outward. Will the universe, too, have an ending of sorts? And what would that mean? If everything we know eventually fades away, does the universe's story matter? One might feel a sense of melancholy that all things will pass. On the other hand, one might argue that transience makes things valuable. A universe that lives and dies might be more meaningful than one that just goes on forever static. These are deeply personal interpretations. Science can tell us what might happen, but it doesn't ascribe meaning that we supply ourselves. There's an old paradox often posed in discussions of cosmic scale. Why is there something rather than nothing? We could equally ask, what if one day there is nothing once again? Does the universe have a purpose, or a narrative, or is it just following physical laws? These questions don't have definitive answers, but thinking about black holes and the end of the universe certainly brings them to the forefront of one's mind. It's both sobering and awe-inspiring to think we might be living in the early spring of the cosmos, destined to witness only a tiny slice of its vast timeline. As we contemplate the cosmos, we also confront the cosmic silence. So far, in all our searching, we have not heard any clear voice other than our own in the great dark. The universe appears eerily silent when it comes to other civilizations or life, at least in our neighborhood. Some find this silence peaceful, while others find it unsettling. In the far future scenarios, that silence becomes absolute. A universe without observers, or with perhaps only the loneliest of observers, is a quiet place. The Fermi paradox asks, if life is not extremely rare, where is everyone? Perhaps life is rare indeed, and we are among the first, and the universe is young. Perhaps intelligence usually doesn't last long, cosmically speaking, or perhaps the distances are just too great and the signals too faint. In any case, right now, when we look up at the night sky, we do not see obvious signs of company. We're contemplating these cosmic truths essentially alone, as far as we can tell, which adds an introspective, almost spiritual quality to the exercise. Writers of cosmic horror, like H.P. Lovecraft, tapped into a certain emotional response to these ideas, one of insignificance and fear. Lovecraft wrote of humans as tiny specks in a cosmos full of ancient, indifferent or malevolent entities. In his imagination, just learning about the true scale and uncaring nature of the universe could drive a person mad. He populated his stories with incomprehensibly powerful beings, like Azathoth, a blind idiot god seething at the center of the cosmos, which in a way mirrors a black hole at the galactic center, a powerful presence we can't communicate with or fully understand. Another early 20th century writer, William Hope Hodgson, wrote The Nightland, a novel set in a distant future where the sun has died and darkness covers Earth, with humanity's last remnants besieged by monsters in the dark. These works capture a fear of cosmic darkness and the end of light, a fear we touch when considering the universe's end. But alongside cosmic horror, there's also cosmic awe and wonder. Think of Carl Sagan, who found beauty and uplift in our connection to the universe. Sagan often reminded us that we are star stuff, that the universe lives within us as much as we live within it. Far from being terrified by our smallness, he was energized by it, seeing our existence as a way for the universe to know itself. When he looked at the possible end of everything, he did so with curiosity and a kind of gentle acceptance. These two emotional tones, dread and wonder, are both valid human reactions. As we have this conversation in a calming tone, we lean more toward the wonder and contemplation side. Instead of fear of insignificance, we can choose to feel the tranquility of being part of something vast and enduring, even if it won't last forever. The darkness at the end of time can be seen not as a horror, but as a kind of cosmic slumber. Consider the idea of the big freeze or heat death, which we will detail soon. A state where the universe goes dark and quiet. One could view that as a terrifying, lonely end, but one could also view it as the universe finally at rest, after an eternity of activity, a final peace. Neither interpretation changes what it is, but it changes how we feel about it. We also find ourselves reflecting on the purpose or significance of it all. Does the universe ending negate what came before? Did all the galaxies and lives and loves that existed during the bright ages matter, if in the end everything is cold? This is a profound philosophical question. One might draw an analogy to personal life. Our lives individually end, yet we find meaning in the transient. Perhaps the value is in the journey, not the destination. In that sense, the universe having an end doesn't nullify the grandeur and beauty that existed when it was vibrant. Some thinkers even speculate on ways an ending might not be the absolute end. We will talk about the multiverse soon, the idea that maybe our universe is one of many, and others will continue even if ours goes dark. There are also cyclic models. Maybe the universe will be reborn after a death. Ancient cultures often saw time as cyclic. Days, seasons, even cosmic cycles. Modern cosmology largely suggests a one-way progression, but as we'll see, a few modern theories intriguingly echo those ancient cyclic ideas. The cosmic silence we face today, and the potential cosmic death in the far future, also raise existential thoughts about loneliness and legacy. If we are alone, or very rare, as intelligent life, then in contemplating the end of the universe, we're also contemplating, perhaps, the end of mind and consciousness in the universe. Unless life and mind find a way to persist or escape to something beyond, the quiet end would also mean no perspective to even witness it. That is a melancholy thought. The universe would die in obscurity with no one to mourn it. However, consider this. Right now, we are here, thinking about these things. In a way, we give the universe a voice and a mind just by contemplating it. The atoms that were forged in ancient stars now compose brains that can project billions of years ahead. That is a remarkable phenomenon. A temporary, small window in which the universe is not silent, because we are here to ask questions and tell stories. We may be ephemeral, but while we're here, we bring meaning to the cosmos simply by appreciating it. And so, as we prepare to venture into discussing the end of everything, we do so with a kind of reverence and calm. The scale of these times and spaces can be intimidating, but we've seen that by taking it slowly, piece by piece, we can wrap our minds around even the fate of the universe, at least in broad strokes. We find that even in the face of an eternal nightfall, there is mystery, and even a kind of beauty in the idea of a final cosmic night. Ultimately, whether one feels horror or wonder, despair or enlightenment at these ideas, it highlights how intertwined our scientific understanding is with our human feelings. The cosmos is not just out there, it's also within us in how it shapes our perspective. By confronting the idea of an end, we actually learn about ourselves, about our hopes, fears, and values. All these musings, whether they provoke fear or hope, highlight the profound impact of cosmic knowledge on our inner world. How we emotionally respond to the idea of an ending, or our place in the vast cosmos, can be as revealing as the science itself. And so, carrying both our knowledge and our reflective wonder, we turn now to the future, to what might await the universe in the eons to come, and what ultimate destiny lies ahead. Let us now lift our gaze from individual black holes and speculative wormholes to the grand stage of the universe as a whole. We have touched on time and entropy, and we've followed the life cycle of a black hole from birth to possible evaporation. What does this tell us about the ultimate fate of everything? As we gently float in our thoughts, we can imagine the future of the cosmos unfolding in slow motion over unimaginable epochs. Right now, we live in what's called the stelliferous era, the age of stars. It's a marvelous time with galaxies full of shining stars, nebulae, planets, and all the complexity that comes with them. But even this era will not last forever. Stars are born from clouds of gas, and that gas is finite. Over tens of billions to trillions of years, star formation will wind down as galaxies deplete or lock away their available gas. The existing stars, one by one, will burn out. Our Sun, for example, has about 5 billion years left, after which it will swell into a red giant and then shed its outer layers, ending as a white dwarf slowly cooling. Far smaller stars, red dwarfs, can live much longer, trillions of years, but eventually they too will exhaust their fuel. Looking ahead, in perhaps 100 trillion, 10^14 years, the formation of new stars will essentially cease across the universe. The lights will start going out, one by one, as the last generation of shining stars uses up its fuel. The galaxies, which once gleamed with billions of stars, will grow dimmer. What remains are stellar remnants, white dwarfs, cooling embers of sun-like stars, neutron stars, ultra-dense remnants of supernova explosions, and black holes. This next era is often called the degenerate era, using degenerate in the physics sense referring to degenerate matter like white dwarf matter, not in a moral sense. In that far future time, the universe will be a very different place. Imagine a galaxy like our Milky Way. Instead of dense clusters of bright stars, most of the light comes from occasional flares, perhaps a white dwarf in a close binary system accreting matter and erupting as a nova, or the merger of two white dwarfs producing a supernova. But these flashes will be fewer and further between as time goes on. Planets, if any still orbit the remaining embers, will have long since frozen in the dark without starlight, unless they hug close to a faint white dwarf. If protons, the particles at the core of atoms, are unstable and eventually decay, some theories predict a very long half-life for protons, like 10 or 34 years or more. Then given enough time, even matter itself will dissolve. A lone neutron star might eventually evaporate particle by particle, or a cold iron white dwarf might quantum tunnel into a neutron star or black hole state. If protons do not decay, matter can stick around much longer, but it can still change via quantum tunneling over absurd timescales. For instance, after 10 or 1500 years, some have speculated even iron stars could collapse. In any case, as we advance trillions upon trillions of years, the dominant objects will be black holes, which can swallow some remnants or merge with each other, and isolated particles and photons thinning out. As time marches on, gravitational interactions will gradually unbind many structures. Stars that still orbit in galaxies may one by one get gravitationally slingshotted out into intergalactic space or get gobbled by black holes. Planets will likely have long been stripped from their orbits. Over quadrillions, 10, 15, and quintillions of years, galaxies themselves might disperse as their remaining constituents escape. Gradually, we enter the black hole era. By around 10-40 years, again assuming proton decay, or even if not, eventually, black holes are basically the only significant masses left, along with extremely cold, dilute gas and elementary particles. Black holes will dominate because everything else has either decayed or been swallowed. These black holes, large and small, quietly roam a now very empty, dark universe. Over immensely long times, even these black holes will begin to vanish via Hawking radiation. Smaller black holes evaporate faster, so the less massive ones will go first, popping off in little bursts. The giants, like the ones in galactic centers, will take far longer. A black hole with the mass of the Sun takes 10⁻⁻⁶ years to evaporate. One with 1 billion solar masses takes around 10⁻⁹ or 10⁻100 years. Some calculations suggest the largest possible black holes, if superclusters collapse into huge ones of trillions of solar masses, could last up to 10⁻106 years. But eventually, even these would evaporate. When a black hole finally ends, it emits a last burst of radiation and particles, and then that something becomes nothing, aside from the emitted radiation flying outward. After the last black hole has evaporated, we reach the dark era. The universe at this point is incredibly vast, having kept expanding all along, and incredibly cold. All that remains are stray subatomic particles and photons, particles of light, but so thinly spread that, on average, you might have to travel trillions of light years to encounter another particle. It's as close to nothing as the universe can realistically get, an asymptotic approach to true emptiness. In this dark era, the temperature of the universe is effectively zero. Though there are still photons, their wavelength is stretched to essentially infinite by expansion, so they are extraordinarily cold. Time still passes, but with virtually nothing happening, time becomes almost irrelevant. If a tree falls in a forest with no one around, does it make a sound? We might ask, if time passes with no events to mark it, does time matter? This is what we meant by the end of time potentially being when there's no change left. This scenario of inexorable decline is often called the heat death or big freeze of the universe. It's currently the most commonly accepted end scenario, given our understanding that the expansion of the universe is accelerating due to dark energy, and appears it will continue forever. Yet, it's not the only scenario that has been considered. Another is the Big Rip. This would occur if dark energy is not constant, but instead grows stronger over time, a form of phantom energy. In the Big Rip scenario, the accelerated expansion becomes runaway. At first, galaxies accelerate away from each other, as we already observe. Then, perhaps a few billion years before the end, the expansion rate becomes so extreme that gravity can't hold galaxy clusters together. Clusters dissolve. As the expansion further ramps up, individual galaxies themselves fly apart as their stars can't stay gravitationally bound. Then star systems are torn apart. Planets drift away from their stars. In the final minutes, stars and planets and eventually atoms themselves would be ripped apart as the fabric of space zooms outward at an infinite rate at the moment of the rip. Essentially, at a finite time in the future, the scale factor of the universe becomes infinite. Everything, even the space within atoms, is being stretched uncontrollably. It's a dramatic, catastrophic end. The universe, in a sense, shreds itself. Based on current data, the Big Rip is not considered likely. Dark energy seems constant, or at least not so extreme, but it remains theoretically possible if our measurements are off or dark energy changes behavior. If the Big Rip were to happen, one could pinpoint a time for the end. One paper calculated, for a specific model, about 22 billion years after the Big Bang for the final rip. That number changes with different assumptions. If we dial back time's arrow and imagine a different fate, what if the expansion reversed? That scenario is the Big Crunch. If the universe had enough matter, and if dark energy was something that could eventually diminish or reverse sign, gravity could eventually halt the expansion and pull everything back together. Galaxies would start to rush back towards each other. Over time, they'd merge, and the universe would become hotter and denser again. Background radiation would blue shift and brighten. In the final phase of a Big Crunch, all matter and light would implode into a super-hot, super-dense state, perhaps symmetrically completing the cycle started by the Big Bang. Some theories that involve a Big Crunch say it could then rebound into a new Big Bang, giving a cyclic universe: Big Bang, expansion, contraction, Big Crunch, then bang again. This was a popular idea earlier in the 20th century, but evidence now strongly suggests we don't have enough matter to trigger a crunch, and dark energy is pushing things apart indefinitely rather than pulling them back. So a Big Crunch, while a fascinating possibility, looks unlikely in our universe, given current knowledge. We should also mention a more sudden and exotic possibility: vacuum decay. It's somewhat related to the multiverse idea we'll discuss in a moment. It's possible that the current vacuum of space, the configuration of quantum fields that is essentially empty space, is not ultimately stable, that there is an even lower energy state it could transition to. If so, the universe could decay to that state via a quantum tunneling event. If such an event occurred at some point in space, a bubble of true vacuum would form and then expand at nearly the speed of light, converting everything it swept through into a new reality with different constants of physics. It would be, effectively, the universe rebooting itself in a bubble, and for anyone or anything in our current universe, it would be lethal and sudden. The walls of the bubble move at light speed, so you'd never see it coming. Vacuum decay is a theoretical doomsday that could in principle happen at any time, but fortunately current calculations suggest if our vacuum were unstable, the decay likely would only occur after extremely long times, far longer than the current age of the universe. And it might never happen at all if our vacuum is truly stable, or only metastable, with a lifetime trillions upon trillions of years longer than the age of the universe. It's a remote, but not entirely ruled out idea. Now, when considering these scenarios, we also naturally wonder, what about life, consciousness, and intelligence? Will they find a way to survive or matter in the far future? Earlier, we talked about the possibility of advanced civilizations around black holes or using exotic technology. Some optimistic speculation has been done in this vein. Freeman Dyson, a visionary physicist, speculated in the 1970s about how life, or machines, could adapt to an ever-cooling, expanding universe. In a paper titled Time Without End, he imagined that as stars fade, an advanced civilization could switch to new energy sources and also slow its subjective experience of time. Essentially, beings could hibernate for longer and longer periods, using minimal energy, then briefly wake to do computations or conscious thought, then return to hibernation. If the intervals of wakefulness increase exponentially, the total number of thoughts or computations could be infinite, even though the available energy is finite. Thus, life could have an eternal subjective experience. This was under assumptions of a universe that expands but at a decelerating rate, without runaway dark energy. In such a scenario, Dyson argued, life could rearrange its schedule to last arbitrarily long. However, once it was discovered that the universe's expansion is accelerating, dark energy, that throws a wrench into Dyson's beautiful vision. In a perpetually accelerating universe, there is a horizon that limits how much energy can be gathered. Energy from beyond a certain distance will never reach you. There's a finite amount of free energy any civilization can ever access. And as the expansion accelerates, eventually temperatures approach an asymptotic minimum that might cut short the ability to keep waking up at all. Later analyses indicated that in a dark, energy-dominated universe, one cannot perform an infinite amount of computation with finite energy. There's a hard limit. In other words, the lights will go out, no matter what clever tricks are employed, if dark energy remains our universe's fate. Nonetheless, Dyson's thought experiment is inspiring. It shows the kind of resilience and ingenuity we can imagine life might have in principle. Life in the universe, given billions of years of advancement, might be extraordinarily adaptable, perhaps reshaping itself, merging with AI, dispersing into distributed networks, or doing things we can't even conceive. If some form of intelligence exists at those later times, they might undertake grand projects, like moving stars to stave off darkness, for instance, starlifting, or creating new stars from dead ones by collisions, or constructing artificial habitats around neutron stars or black holes to eke out trillions more years of energy. Science fiction authors have indulged in such far future speculations. Societies migrating to the last red dwarf stars, or uploading consciousness into photon pulses to race around black holes. However, eventually the possibilities narrow. If heat death is the end, then unless new physics provides an escape hatch, such as tunneling into a new universe or altering the vacuum, there comes a point where no strategy can squeeze more useful work out of the cosmos. Perhaps life could linger near the very last black holes, feeding off their hawking radiation for quadrillions of years. But when those are gone, all that's left is diffuse, unusable energy. One fanciful idea is that perhaps in the far future, life might attempt to create new universes, a kind of cosmic genesis project, thereby seeding continuation elsewhere. Some speculative theories have suggested it might be theoretically possible to trigger a pocket universe, though how one could do that, and whether it's allowed by physics, is unknown. If such were possible, perhaps the legacy of life in this universe would be new universes carrying on new stories, a kind of cosmic reproduction. This is firmly in the realm of speculation, but it's a thought that combines hope with the acknowledgement of an end. Life might not defeat the end in this universe, but could give birth to something new beyond it. Before we entirely close the book on fate, we should acknowledge the idea of a multiverse. If our universe is just one of many, perhaps one bubble among countless others, then the end of our universe might not be the end of all existence. Some cosmological models of eternal inflation suggest that the Big Bang that started our universe might be just one pocket of an ever-inflating grander space, where other Big Bangs happen in other regions, continuously creating new bubble universes with possibly different properties. In that view, new universes could be forming even as ours ages. If that's true, while our bubble may fall silent in a heat death, other bubbles may still thrive or give rise to yet more. Another multiverse notion comes from quantum mechanics, the many worlds interpretation, where every quantum event spawns a branching of reality. In that interpretation, there is a stupendous number of parallel universes, constantly splitting off. Though it's not the same as traveling to another universe, it suggests a kind of endless ensemble of possibilities. Even the death of our cosmos in one branch might be just one leaf on the tree, while other branches have different outcomes. We also touched on a more cyclic idea. What if the end leads to a beginning? Roger Penrose, a respected physicist, has proposed a model called Conformal Cyclic Cosmology, CCC. He suggests that in an eternally expanding universe that has reached heat death, the distinction between space and time can become blurred. If all particles lose their mass, which could happen in an ultra-emptied, cooled universe, according to certain ideas, and there are no structures left, the geometry of the universe might be interpreted in a conformal way that can be mapped to a new Big Bang. Essentially, the infinite future of an old, empty universe could be mathematically equivalent to the hot, dense state of the next Big Bang. In CCC, our Big Bang was not the absolute beginning, but the continuation of a previous aeon. And after an unimaginably long duration, our universe's remote future will seed the next aeon's Big Bang. It's a radical and controversial idea, and evidence for it is tentative. Penrose has claimed some patterns in the cosmic microwave background might be signs of black hole collisions from a past aeon. This is debated. If by chance CCC or something like it were true, it means the story never truly ends. It repeats in grand cycles. Time would be both infinite and circular in a sense. We must admit that these far future speculations, while grounded in extrapolating known physics, become uncertain because we don't know if new physics might intervene. Perhaps dark energy decays. Perhaps new particles emerge over time. Perhaps intelligence plays a role, etc. But within what we know, the big freeze, heat death, is the leading candidate for our universe's fate. Now, having canvassed these scenarios, let's try to paint a picture of the far, far future in a narrative way, keeping it gentle. Imagine you have a magical time-lapse camera and could speed up the universe's clock. At first you see stars moving in galaxies, maybe colliding, and galaxies merging. That's the next few billion to tens of billions of years. Then the lights in the galaxies start to wink out. The universe's window grows dark, with only the afterglow of red dwarfs and the embers of white dwarfs marking the scene. Nebulae fade. Everything settles into quiet. Planets, if any, circle dead stars or remnants. Many wander free in space after being cast out. Fast forward further. Galaxies themselves become gravitationally unbound, especially under the influence of dark energy. A lone white dwarf, maybe accompanied by a black dwarf. A white dwarf that has cooled to near invisibility, though these haven't had time to form yet in our current 13.8 billion-year-old universe. They'd form after quadrillions of years when white dwarfs cool completely, drifts through the darkness with no sun-like star left shining. Occasionally, maybe once in a blue moon of a blue moon, two of these remnants meet and merge, sparking a brief light, a supernova or a new black hole formation. But those events become exceedingly rare, as trillions turn to quadrillions, and further, black holes slowly eat what they can and hold court while everything else decays. The backdrop temperature from cosmic background radiation goes from a few Kelvin now down to tiny fractions of a Kelvin and keeps dropping. If proton decay happens, one by one, the very atoms of leftover matter begin to fall apart into radiation and lighter particles. If it doesn't, matter might still eventually find its way into black holes or get ejected into the void by gravitational encounters. Time becomes a passing of eons without much change. Starless, black hole-dominated galaxies, or rather former galaxies, carrying on. Eventually, black holes begin to evaporate. Smaller ones go pop. Larger ones take far longer, but their mass slowly drips away. In the final flickers of time, perhaps the last thing of interest is a gargantuan black hole in what was once a galaxy cluster, now isolated. It shines faintly in radio waves from its hawking radiation, like an extremely cold furnace that very gently glows. Over absurd time spans, it shrinks. As it reaches about the mass of a mountain, it emits more strongly, though still not nearly enough to be bright at cosmic distances. In its last second, it releases as much energy as billions of nuclear bombs, a brief flash in an empty theater, the last fireworks. After that, darkness. The universe is a vast, expanding volume of nearly nothing, just dilute photons and perhaps some electrons, neutrinos, and other light particles flitting about. The expansion continues, so those particles get more and more separated and lower in energy. If you were an immortal being at this point, with some magic to survive without energy, you would basically see nothing, hear nothing, feel nothing. The night sky wouldn't even have a single star or any glow. It would be black in all directions, at all wavelengths, to the limits of your eyes and instruments. Space would be extremely cold and getting colder, though absolute zero would never be reached, just approached asymptotically. Time would lose its meaning because nothing happens. This is the eternal nightfall of the cosmos, the quiet, final state as currently envisioned. Yet, as we have said, it could be a beginning in disguise if a multiverse exists, or if Penrose's cycles are correct. But within our observable frame, it's an end. Now bring your mind back to the present. That far future is essentially unreachable for us except in imagination. But contemplating it gives a profound perspective. It makes our time of billions of years of starlight seem like a golden age. A mayfly's day in cosmic terms, brimming with colour and life and activity. It also places everything in context. The struggles of living beings, the formation of planets and stars, the evolution of galaxies, all are part of the life of the universe. We started by thinking about black holes and have arrived at thinking about the end of time. Black holes, in a way, were an appetizer for the concept of things ending. They are places where stuff goes and doesn't come back. The heat death is the final such place, where all things end up in a state from which no new beginnings within that system can arise. Perhaps surprisingly, this contemplation doesn't have to be depressing. It can be oddly peaceful. One can imagine the universe in its old age, having lived a full life of trillions of years, now settling into a deep rest. In human terms, all things that live eventually die, and there is a symmetry and naturalness to that. We don't know if the universe had to end, but given the laws as we know them, it seems to. Standing at the shore of this vast timeline, we can feel grateful to exist during a time when we can witness the cosmos in its youthful bloom. And we can be humbled by the sheer scale of past and future around us. Our journey has been both intellectual and meditative. We roamed from present reality, stars and black holes we observe, to speculative edges, white holes, wormholes, then to philosophical introspection, and onward to cosmic destiny. It's a lot to take in. If your eyes are growing heavy with the weight of eons, that's okay. This narrative is meant to be absorbing, but also gentle enough to lull you toward rest, if that's what you seek. So, as we near the end of part 1 of Eternal Nightfall, let's recap softly. Black holes taught us about extremes of gravity and time. They are like nature's deep wells, showing us how the flow of time and fate of matter can change under strong gravity. They serve as a link between the brilliant present universe and the dark future. They are both products of the era of stars and seeds of the era of darkness, since they last so long and eventually evaporate to bring about the final balance. From them, we learned about the persistence of information, no escape, yet no destruction, setting the stage for understanding that even an end might not be absolute in every sense. We considered that the universe may keep its secrets, even in an end, or even renew itself. We acknowledged our feelings about these prospects, a mix of trepidation and tranquility. For now, we let the mind rest on these deep vistas of time and space. The universe in its infancy was full of light. In its old age, it may quietly fade into darkness. And yet, even in that darkness, there can be wonder, black holes softly glowing as they evaporate, particles occasionally flickering into existence, perhaps the seeds of new universes beyond our perception. There is a kind of peace in the idea of the cosmos eventually coming to a calm, quiet state after all its tumult. Take a deep breath and imagine standing at the end of time, gazing at the last weak glow of the last matter as it disappears. It might be a lonely scene, but it is serene, the finale of an almost eternal story. In that silence, every struggle and noise of earlier times has faded into memory. What remains is the simple fact of existence itself, spread thin, but still there, a testament to the persistence of reality. In part 2 of this documentary, we will continue our exploration of these profound themes. We will delve further into what the end of time might mean, look at how these ideas have appeared in human thought and culture, and consider if there are ways in which an ending could lead to something beyond, such as a multiverse or a rebirth. We'll maintain our gentle, mysterious tone as we navigate those deeper waters. Until then, let this calm, cosmic journey settle gently in your mind, the lullaby of the universe, the quiet hum of distant stars, and the soft stretch of space-time can accompany you into rest. We have travelled from the blaze of galaxies to the stillness of heat death, and found beauty at every step. The story isn't over. There is more to ponder, more dreams to dream. Even as we close this chapter of the journey, the story of the cosmos continues to unfold in our imagination. For now, we drift in the cosmic night, content in understanding and wonder, letting the enormity of it all inspire a deep, reflective peace. The voyage will go on, and we will be there to continue it, ever deeper into the eternal nightfall of the cosmos. And so we find ourselves drifting further into the cosmic abyss, enveloped by an endless, velvety darkness. All around, stars glimmer faintly like distant fireflies caught in an eternal twilight. There is a profound silence here, beyond the edges of what we once knew, a silence filled with the weight of eons. In this quiet, mysterious gulf, we continue our gentle descent, deeper, slower, toward the heart of a great black hole. The event horizon lies just behind us now, that one-way threshold we crossed as lightly as a dream crossing into deeper sleep. For a black hole as gargantuan as this one, crossing its event horizon is eerily subtle. There is no sharp boundary or jolt as we pass through, no more drama than stepping through a shadow. We simply find that we can no longer turn back. If we look behind us, we can still see that halo of distorted starlight marking the edge, but from here on, all paths lead inward. Inside this enigmatic realm, everything feels transformed. The silence here is unlike any silence we have ever known, total and all-encompassing, broken only by the faint rhythm of our own existence. The usual certainties of direction and time begin to blur. Deep ahead of us in the blackness lies the unseen singularity, the very heart of this black hole where all paths converge. We cannot see it. It remains veiled in darkness and mystery, a place where the known laws of physics falter. Around us, the immense gravity holds us in its powerful embrace. And just behind and above, the event horizon we crossed forms a strange glowing halo. It is the last glimpse of the outside universe, light from distant stars bent into a ring by gravity's lens. It is like a fiery halo around a void, an ethereal ring where the entire universe outside is smeared into a brilliant band of light. The black hole wears this ring like a glowing crown, a last remnant of the world we left behind, circling its darkness. This black hole, born from the death of a colossal star and fattened by eons of feasting, holds within it an unfathomable trove of matter and secrets. Yet it follows nature's laws faithfully. Nothing of what it has taken in is truly forgotten. With each star, each atom it swallowed, the black hole grew more massive, and its event horizon expanded like a growing shadow. In doing so, it also grew more chaotic in a sense, increasing in what physicists call entropy, a measure of disorder, or perhaps of hidden information. It's as though all the consumed pieces of the universe have left whispers of themselves imprinted on the black hole's boundary. Some theorize that the horizon of a black hole encodes every detail of what falls inside, like a cosmic ledger or a hologram of information. If so, then even in this darkness, nothing is truly lost. The information is woven into the very fabric of the event horizon, preserving a ghostly memory of all that has passed its threshold. It's a mind-bending thought, the surface of a black hole as a cosmic ledger or library, recording everything that ever fell inside, even though no one can read it from the outside. Despite its voracious appetite and crushing gravity, this dark titan is not completely silent. In the depths of its shadow, it emits the faintest whisper of light, known as Hawking radiation. A subtle, ghostly glow, far too feeble for our eyes, but real nonetheless. Over inconceivable spans of time, this radiation will slowly carry away the black hole's mass, particle by particle, photon by photon. It's as if the black hole is a very slowly leaking vessel, drip by drip releasing what it swallowed. But for a giant such as this, that evaporation is unimaginably slow. Trillions upon trillions of years would barely whittle it down. To us, the black hole appears effectively eternal, its lifetime stretched over time scales beyond comprehension. Still, the idea lingers that someday, in the farthest future, even this mighty darkness could finally dissolve, releasing everything it ever held in one final sigh of starlight. We hover in a realm where even time itself has slowed to a crawl. Each heartbeat, each thought feels drawn out and unhurried. Looking out toward the universe we left behind, we notice something strange and wondrous. The stars beyond us are evolving in fast forward. From our perspective, deep in this gravity well, time outside races ahead, while for us, it lingers. Moments ago, those distant stars were as we remembered, but already they begin to shift and age subtly before our eyes. It is as though we have stepped into a time machine of sorts, where we remain in tranquil, slow motion as the cosmos outside surges onward. Years flash by in the outside cosmos like seconds. Decades and centuries whirl past, then millennia. To us, it feels like we're fast-forwarding a cosmic film. Stars shift positions as though dancing a slow ballet that we have sped up. 1,000 years, 10,000 years. In moments, such spans are gone. Soon, even 1,000,000 years becomes a trivial flicker. It's a perspective few could ever imagine, 1 foot at the edge of forever. This distortion of time is the black hole's doing. Its immense gravity stretches time and space like taffy. To a faraway observer, we would appear almost frozen at the brink of the event horizon, hanging there for eternity. But from here, in our own reality, time flows normally for us. It's the rest of the universe that seems to be moving on without us, rushing into the future. We are in a dreamlike state where 1 second here might correspond to years out there. We can, in essence, watch the future unfold while we linger in the present. It's a perspective few could imagine, 1 foot at the edge of forever. And so we watch, in wonder and melancholy, as the universe ages before us. At first, only subtle shifts are visible as centuries and millennia elapse. But as we let even more time pass, the changes become more dramatic. Years turn into millennia, millennia into millions of years, and the slow evolution of the cosmos accelerates in our sight. What was once static now evolves. Distant stars live and die in the blink of an eye from our perspective. We see distant suns swelling into red giants and shedding their outer layers in glowing nebulae. Our own sun will someday do this as well. In about 5 billion years, it will swell into a red giant, engulfing the inner planets and shedding its outer layers. For a brief time, our solar system will be illuminated by a gorgeous planetary nebula, expanding shells of the sun's own substance, cast off into space, and at the center, a tiny white dwarf, the sun's remaining core, will shine like a diamond in the cosmic night. We catch the sudden flare of a supernova as well, a titanic star ending its life in a burst of brilliance, shining intensely for a brief moment before fading. In our accelerated vision, it appears as a sudden flash of light, a celestial firework marking the death of a star. Elsewhere, massive stars collapse, the blue-white giants that burn through their fuel in mere millions of years, and erupt as supernovae, brief blossoms of light scattering star stuff into space. Each brilliant flash is the silent farewell of a star that had shone for millions of years, now gone. In the darkness that follows, neutron stars and black holes are born from those stellar graves, adding to the collection of strange objects in the cosmos. Galaxies themselves begin to transform over the eons. Some galaxies twirl together and merge in slow gravitational dances, as will happen when our own Milky Way galaxy collides with the Andromeda galaxy billions of years hence, their stars intermingling in a grand cosmic dance, then spin down as one. For a moment, these cosmic mergers spark fresh star birth, bright new blue stars igniting out of the gas stirred up by the collision. But that moment is fleeting on the timescale we witness. Soon, the fire of creation wanes. The fuel for new stars grows scarce as the great galactic engines use up their gas. The night skies of those future galaxies grow emptier, with fewer newborn stars to replace the dying ones. As billions turn to trillions of years, the universe expands relentlessly. Distant galaxies recede from each other faster and faster. The fabric of space stretches like an ever-expanding ocean, carrying island universes away over the horizon. One by one, the galaxies that once dotted the sky vanish from view, redshifted into invisibility by the growing distances. Each disappearance leaves the cosmos a little darker, a little lonelier. Clusters of galaxies that were gravitationally bound remain together for a time, but eventually even they feel the pull of expansion. In the far future, only the remnants of our local group of galaxies may cling together. Everything else slips beyond reach into the eternal night. If the expansion continues indefinitely, each region of the universe becomes an isolated isle of whatever matter remains, marooned in an ocean of increasing nothingness. Within the remaining galaxies, the starry lights continue to go out. The large, hot stars died early, leaving long-lived red dwarf stars to carry the last torches of fusion. These small red suns burn their fuel slowly. In fact, red dwarfs are so thrifty with their fuel that none have died in the universe yet, even after all these eons, lasting trillions of years, far longer than any star that came before. We watch as even these steadfast embers begin to dim. One by one, the red dwarfs flicker and expire, turning into faint white dwarfs, hot cores of stars left to cool in the dark. No new stars form now. The cosmic gas is depleted or too diffuse. The age of starbirth is over. It is the twilight of the cosmos, where only fading stars remain. In our accelerated view, We see centuries pass in an instant and millennia flash by like a breath. The death of each star feels poignant, yet peaceful. These suns had shone for billions of years, nurturing any worlds around them with light and warmth. Now they quietly bow out. Their lives, so incomprehensibly long to us, come to an end, reinforcing that even celestial things are not eternal. There's a sense of cosmic mortality in witnessing star after star go dark. Yet there is also a gentle acceptance. This is the natural order of things on a grand scale. Now the universe enters its old age. All that shine are the cooling white dwarfs and the occasional flare of a dying star going nova. Let us pause our cosmic fast-forward here and imagine, for a moment, what it might be like to exist in such a late epoch of the universe. Picture a lone planet orbiting one of those last faint white dwarf stars. Night falls on that planet, though night is hardly different from day now, as its sun is so feeble. The sky above is almost completely black. No Milky Way band of countless stars greets the eye. Only an empty expanse, with perhaps a few dim red points of ancient starlight still visible, if any at all. The galaxy that planet belongs to has long since lost its sparkle. Only cinders of stars remain. Perhaps our imaginary observer on that world can make out, faintly, the pale glow of the white dwarf sun around which their planet circles. Maybe a neighbouring dead star occasionally flares if it siphons some gas and erupts in a nova. But otherwise, the heavens are still. It would be a sky far more silent and lonesome than any night we know. And yet, maybe that observer would find it peaceful. The eternal gentle night above, unchanging and calm. They might gaze at the faint outline of the dark galaxy, seeing not despair, but the quiet grace of a universe at rest. In that profound darkness, perhaps they would feel the same kind of awe and tranquility that we feel under a starry sky, proving that even in a nearly starless cosmos, there can be beauty and solace. Now we leave that silent world and return to our vantage outside time, letting the eons resume their course. All around it is darkness now. The last lights are weak and red, then altogether invisible as their heat dissipates over quadrillions of years. Imagine a white dwarf the size of Earth, once the heart of a sun, now cooled to a black dwarf, a cold cinder in the infinite night. Around it orbit ghostly planets, frozen and dark, relics of a solar system long gone. Such scenes play out everywhere, the once brilliant galaxies now littered with dark remnants, like a city at night with only a few glowing coals where street lamps once burned bright. The cosmos has grown still and quiet, yet even now there are occasional glimmers of activity. In this far future, the only substantial energy releases come from gravity and quantum chance. Once in a great while, 2 dead stars, perhaps 2 black dwarfs or neutron stars, might drift together and merge, unleashing one final burst of light. Or a lone neutron star might finally collapse into a black hole. But these events grow rarer as time marches on. As eons pass, even such occurrences cease. The universe continues to cool and dim. If protons, the building blocks of atoms, are unstable over extremely long times, then slowly, atom by atom, matter itself begins to dissolve into radiation and subatomic particles. The solid ghosts of stars and planets would quietly evaporate into more fundamental constituents, further thinning out the already sparse emptiness. All that remains now are black holes and the diffuse background of elementary particles and photons, thin gruel scattered across expanding space. Black holes, which once were born from stars or even held court at the centers of galaxies, now become the last concentrated things in existence. For ages untold, they persist, slowly losing mass. We recall that even these monoliths are evaporating via Hawking radiation, but over such vast spans that each black hole seems almost frozen in time. Yet as we accelerate further into the future, we begin to see them wane. Small black holes wink out first, vanishing with soft pops of final energy. Larger ones endure longer, but one by one, they too begin to shrink noticeably in our sped-up view. In the unimaginable future, perhaps 100 years or more from the beginning, the last black hole stands alone against the dark. Picture this final titan. Perhaps it was once a supermassive black hole at a galaxy's core, now isolated, the sole heavyweight in an empty universe. It has consumed all it could and outlived all its peers. Now even it must face the end. We watch as it dwindles over eons upon eons, radiating away its mass in a trickle of faint photons. As it gets smaller, it radiates a bit faster, shrinking more and more, until, at long last, it reaches the final phase. In a last brief moment, it glows white-hot, and then disappears. It leaves behind a final burst of light and particles, a brief whisper of all that it was. Then that too fades into the darkness. Now the mighty drama of the cosmos is all but over. No stars shine, no planets circle, no black holes lurk. The universe is a vast expanse of nearly nothingness. A few stray particles, a faint haze of photons so diluted that they rarely, if ever, meet. The temperature everywhere is just a hair above absolute zero, the coldest anything can be. Even the faint afterglow of the universe's birth, the cosmic background radiation that once bathed space in a warm hue, has stretched and cooled into near nothingness. It's now only a whisper of a whisper, almost impossible to distinguish from pure silence. If we thought the void was silent before, it is utterly silent now. This is the big freeze, the heat death of the universe. All differences in temperature and energy are gone. All structure has dissolved. Entropy has reached its maximum, and nothing more can happen because all gradients have vanished. Time itself still stretches on, but it has no milestones, no change. In this eternal night, one could say that time has effectively lost its meaning. It is as though the universe has fallen into a deep, dreamless sleep. From our exceptional vantage point near the black hole, we have witnessed this entire saga unfold. What took countless billions upon trillions of years out there has passed for us like an evening's reverie. We watch the cosmos grow up, grow old, and finally fade. It is a somber sight, yet strangely serene. The end of everything comes not with a bang or a cry, but with a gentle dimming of the lights and a quiet sigh. The universe, once ablaze with 10 billion galaxies, is now a still, black sea. The final stars have flickered out, and an eternal darkness has settled. This ultimate darkness is not violent. It is peaceful in its total silence and stillness. A cosmic nightfall with no dawn to follow. Is this truly the end of the story? It would seem so from the laws of physics as we know them. All paths have led to this utter quiet. With nothing left to see in the outside cosmos, we now feel the black hole's final pull, drawing us further inward, toward its central point of mystery. Up ahead, in the absolute darkness, lies the singularity, the place where gravity crushes matter into an infinitesimal point, and where our understanding of physics breaks down. We drift closer to this ultimate enigma, wondering if it is truly the ultimate end, or perhaps a gateway. With each passing moment, the circle of light from the outside universe that hovers behind us grows fainter and redder as even those last photons struggle to climb out. We are descending into an abyss where no signals can escape. Space and time themselves feel twisted. Forward and downward have become the same direction, carrying us inevitably toward the singularity. In our musings, we imagine what crossing that final threshold might mean. Could falling into the singularity be like breaking through a cosmic egg to emerge into a new realm? All paths in this journey have converged to a single point of darkness ahead. And yet, as we contemplate this eternal night, we find ourselves wondering, is the curtain closed for all eternity? Or could there be something beyond this final darkness? In the emptiness, new questions stir like faint starlight. Perhaps this is not truly the full stop of the cosmic tale. Perhaps there are hidden chapters yet to come, or other stories running parallel to our own. Perhaps, in some far future, the universe might experience a kind of rebirth. One speculative scenario is that gravity could someday halt the expansion and pull everything back together again. Picture the reverse of the Big Bang. Galaxies drawing closer, merging into a blazing heap, eventually coalescing into an unimaginably hot, dense point once more. This would be the Big Crunch. From that state, some imagine the universe could bounce, exploding outward again in a new Big Bang, giving rise to an entirely new cycle of cosmic evolution. In this cyclic cosmos, creation and dissolution follow each other like the turning of day to night and night to day. Some ancient traditions whispered similar ideas. In Hindu cosmology, the universe undergoes endless cycles of creation, days of Brahma, and dissolution, nights of Brahma, each lasting billions of years, not unlike our scientific vision. And the phoenix of legend dies in fire, only to be reborn from its ashes, a poetic symbol of renewal that resonates with these cosmic cycles. The universe would breathe in and out, perhaps infinitely, each epoch a cosmic day, followed by a cosmic night. Our current universe would just be one chapter in an eternal story, destined to be followed by another dawn. Another tantalizing idea involves the mysterious concept of white holes. If a black hole is an entrance with no exit, a white hole is its mirror opposite, an exit with no entrance. Though purely theoretical, a white hole would constantly spill out matter and light, but nothing could enter it from outside. Some thinkers have speculated that the Big Bang itself might have been a kind of white hole, a surge of energy and matter erupting into being. In this view, perhaps our universe was born from the other end of a black hole in some larger meta-universe. The black holes collapse in one reality, becoming a creative outpouring in another. Likewise, every black hole in our universe, as it pinches off space and time, could conceivably give rise to a newborn universe on the other side, where all the information and matter that fell in are reissued in a grand explosion. It's an extravagant vision. Each black hole as a seed of a new cosmos, each universe giving birth to many others through these dark wombs. If any of that were true, then what looks like destruction in our universe would be creation in another domain. Others imagine a multiverse, a vast ensemble of universes where every possible reality exists somewhere. In a multiverse, our cosmos may be just one bubble in an infinite foaming sea of universes. While ours may eventually fizzle out into darkness, countless other universes could be blooming with new light or following their own life cycles. Some might be similar to ours, with galaxies and stars and maybe life, while others could be governed by entirely different laws, utterly alien and strange. In the multiverse idea, creation is not a unique event, but an ongoing, eternal tapestry. New universes are born all the time, and the end of one universe doesn't mean the end of all that exists, just the end of that particular chapter. It's a comforting thought in a way, that existence in some form always continues, that there are other cosmoses beyond ours, spinning out their own endless stories. These concepts, cyclic rebirth, white holes, multiverses, are speculative whispers at the fringes of science and philosophy. We do not know if any of them are real. Our current understanding, as far as solid evidence goes, still points to the quiet, final darkness we witnessed. Yet it is in our nature to wonder, to hope for possibilities beyond the horizon. And so we dream of cosmos beyond cosmos, of light following darkness in perpetual succession. Even in the face of an apparently final end, the human mind conjures up new beginnings. The timescales we have traversed in our imagination are almost unfathomable. We witnessed events that span trillions of years, a duration that defies any human frame of reference. By comparison, the entirety of human history is scarcely an instant. Our own lives are but sparks in the darkness, glowing briefly, and then gone. And yet, it is within the brevity of those sparks that the universe attains consciousness and meaning. Perhaps our mortality and smallness in time make our capacity for wonder even more significant. We appreciate the eternal precisely because we ourselves are not eternal. Standing at the edge of forever, we marvel not just at the cosmos, but at our ability to marvel. It is a gift of the moment, destined to pass, but in that moment, the universe has awareness. We have been distant spectators to the life and death of the universe, but it is we, the observers, who give this story meaning. It makes one wonder, what is the role of consciousness in this vast cosmos? If the universe ends in eternal night with no eyes to see it and no minds to know it, does its grand history matter, or even truly exist in any experiential sense? Right now, as we reflect on these mysteries, we are a part of the cosmos becoming aware of itself. Consciousness, our capacity to perceive, to feel, to think, is one of the most mysterious and profound aspects of reality. From the perspective of physics, we are collections of atoms, born from stars, now able to contemplate stars. We are literally made of cosmic dust that has come alive. Through us, the universe has eyes to look inward and outward, to marvel at its own beauty and complexity. When we stand under a clear night sky and look up, we are literally the universe looking back at itself, a small conscious fragment contemplating the vast whole. It is often said that we are a way for the cosmos to know itself, and indeed, in our minds, the atoms of the universe have begun to understand their origin. Imagine the universe before life. before any consciousness arose. Galaxies whirling in blind majesty, stars burning and exploding in absolute solitude. There was magnificence, but no awareness to appreciate it. With the emergence of life and ultimately conscious beings, a new kind of phenomenon appeared. The universe waking up, if only in tiny isolated pockets. On at least one planet, and surely on others, scattered across the gulfs of space. The cosmos learned to observe, to feel, to question itself. Perhaps life and mind bloomed on countless worlds through the eons, each a small island of awareness in the vast ocean of space. What is this strange spark of awareness? Scientists and philosophers alike struggle to explain how the physical processes in a brain give rise to the subjective experience of being. Some propose that consciousness is purely an emergent property. When matter is organized in a sufficiently complex way, as in our brains, the lights turn on inside. Others have speculated that consciousness might be a more fundamental aspect of reality, present in some faint glimmer, even in simple particles, and growing brighter with greater complexity, a viewpoint known as panpsychism. If that were true, then every part of the universe carries a tiny seed of awareness, and we, with our rich inner lives, are the blossoming of a potential inherent in cosmic matter itself. Whether or not that is so, it remains that consciousness allows the universe to be experienced. Through countless living beings, the cosmos has tasted its own existence. From the perspective of a flower following the sun, to a bird navigating by the stars, to a human mind contemplating the origin of galaxies. Each conscious creature is like a small mirror reflecting a piece of the universe. In this realization comes a profound sense of gratitude and belonging. We, the observers, are not separate from the cosmos, but an intrinsic part of it. The universe unfolds through us, and we give back meaning in return. Collectively, all those reflections form a kind of cosmic self-awareness, however fragmented. It's breathtaking to realize that without conscious minds, concepts like beauty, awe, love, or curiosity would not exist at all. The universe would be simply matter and energy, with no value or meaning. Only in the presence of observers do these qualities arise. Some thinkers have envisioned a kind of universal mind, a network of all consciousness that transcends individual beings. Consider that within our own brains, billions of neurons work together to give rise to a single awareness. By analogy, one might imagine every individual mind as a neuron in a vast cosmic brain, with the universe itself as the emergent consciousness. This is more poetry than science, but it's an alluring idea that maybe on the grandest scale, something like a collective consciousness could exist, one that we are all a part of. When we gaze at the stars and feel a sense of connection or transcendence, perhaps that is the faint recognition of our place in a larger consciousness that spans space and time. Even the patterns we see in the universe invite the analogy of mind, the cosmic web of galaxies, stretching across billions of light years, forms filaments and nodes uncannily reminiscent of the neural networks in a brain. Of course, such visual similarity may be just a coincidence arising from similar mathematics, but it sparks the imagination. In a way, one might poetically say the universe has a mind-like structure and is filled with its own kind of thoughts, galaxies and stars as the dreams of the cosmos. And what about memory? Memory is integral to consciousness. It weaves the past into the present, giving continuity to our identity. Does the universe have a memory? We know that it keeps records of the past in various ways. Every photon traveling through space is a messenger from a bygone time, carrying an image of the universe as it once was. The light we see from distant galaxies is, in effect, the universe remembering itself billions of years ago. In cosmic structures and in fundamental particles, there are imprints of events that happened eons before any mind was there to witness them. In the fading glow of the cosmic microwave background radiation, we have a memory of the universe's infancy, still faintly visible today. Even black holes, as we considered, may encode information about everything that fell into them, storing those memories on their event horizons. So in multiple senses, the universe holds memories of its history, written in light, in matter, in space-time itself. And now, with conscious beings in the mix, the universe remembers intentionally. We record history in books and computers, in stories and myths. We think about the past and plan for the future. The awareness of time's flow, of history and future possibility, is a gift of consciousness. Through us, the cosmos has learned about its own beginnings, and through our scientific instruments and minds, it has reflected on where it might be headed. If one day all consciousness were to fade away, as it seemingly must, if the universe reaches a state of permanent silence, then this rich inner life of the cosmos would cease. No more thoughts or dreams, no more memory or anticipation. Just as a mind slips into unconscious sleep, the cosmos would lie in oblivion with none to know itself. This brings us to a poignant truth. The end of the universe is not just the end of matter and energy's dynamism, but the end of meaning, the end of story. For meaning lives only in minds. In the final, observerless cosmos, even the concept of time becomes ambiguous. Time is defined by change, by clocks ticking, by events unfolding. When nothing happens and no one perceives anything, time becomes like a frozen river. It might as well not be flowing at all. This is the death of measurement and observation. There are no instruments left to mark a moment, no minds left to say now or then. Any lingering particles drift aimlessly without interaction significant enough to distinguish one moment from the next. Every second in that emptiness is identical to the last and the next. In a very real sense, time has died, or perhaps it has merged into an eternal now that never changes. It is a strange thought. The universe could persist indefinitely, yet with no consciousness to experience it, and no events to differentiate the passage of time. It is as though existence ceases to be in any meaningful way. All that remains is a dark, quiet canvas, with no artist to paint and no observer to admire. The final chapter has no reader. The grand symphony of the cosmos has played its last note, and now that note fades into a silence that will last forever. And yet, while this ending is profound and wistful, it is not tragic in a human sense. It simply is. Over incomprehensible billions and trillions of years, every possible story was played out. Every star lived and died. Every atom had its moment. The cosmos explored the full range of its possibilities, and then came to rest. There's a serenity in that thought. After all the turbulence of creation, the universe finds peace. The eternal night that follows is calm, untroubled by any storm. Perhaps a sleep that lasts until a new dream begins. Perhaps the universe itself dreams in that state of perfect rest, dreams of all the stars and galaxies it had, dreams of new worlds that could yet be. If there is a cosmic mind pervading all, maybe that mind doesn't die but drifts in an endless reverie, quietly imagining new realities in the cradle of nothingness. As we float here in our imagination, contemplating this far distant future, we too feel a profound sense of calm. The end of the universe, as remote and abstract as it is, mirrors a state of deep rest. It is as if the cosmos has finally gone to sleep, drifting into a slumber from which there is no waking, or perhaps a sleep that lasts until some new dawn, in another reality, sparks a new dream. In this quiet moment, we let the enormity of it all wash over us. The mind grows still, like the stillness we've been envisioning, the mysteries we've pondered, black holes, the end of time, the nature of consciousness. Settle gently in our thoughts, no longer pressing for answers, just floating alongside us like stars in the night. We have traversed such vast ideas, and now we lay them down softly. There is nothing more to seek tonight, nowhere else we need to go. Our mind and heart find rest in the acceptance of not knowing, in the wonder that remains. We find ourselves breathing slowly, in tune with the slow rhythm of the sleeping universe we imagined. Our muscles unwind their tension. We feel as if we are floating, weightless and serene, like a tiny mote carried on a vast, calm sea. Every part of us is unburdened. The universe's final night is not something to fear. It is the culmination of a grand journey. So too, in our own small way, we end our journey for now. Enveloped in the darkness of our room, under the blanket of the night, we feel connected to that vast cosmic night. We realize that darkness can be gentle, that an ending can be tranquil. The blackness around us is not merely an absence, but a soothing presence of its own. Like the soft dark behind closed eyelids, it harbors peace and comfort. Just as day gives way to restful night, the era of light in the cosmos gives way to an era of rest. In that perspective, our own night and sleep feel like part of the cosmic cycle, a tiny mirror of the universe's ebb and flow. Allow yourself to sink into that comforting darkness now. We let ourselves sink into that comforting darkness. We are not lost. We are at home in the vastness. We are safe here, cradled by infinity. Our worries and thoughts drift away, just as stars eventually drift into the night. Nothing urgent remains, nothing at all to do or solve in this moment. We float on the edge of sleep, carried by a universal lullaby. Like a star that has expended its energy, we gently dim into softness, our minds quiet and calm. There is a profound silence, not empty, but full of acceptance. We are floating in the void, but we are not lost. We are at home in the vastness. We are safe here, cradled by infinity. As the cosmos breathes its final sigh and falls into eternal nightfall, we too surrender to the present stillness. In this eternal night, we are weightless and free, united with the boundless peace that the end of all things brings. Feel how the mystery and wonder of it all have gently escorted us to this state of tranquility. Our journey through time and space in this story has been long and wondrous, and now it comes to a gentle close. Let our own consciousness drift like a slow comet through the dark, until even that motion ceases and all is at rest. There is only the soft darkness and the quiet of a universe at peace. In the farthest reaches of time, long after the last stars have flickered out and the final black hole has quietly dissipated, the universe lies in an almost unfathomable silence. That final black hole, once the last titan of gravity binding the darkness, eventually evaporated away with a silent, gentle flash of Hawking energy, a final brief whisper of light as its farewell. After that lonely ember faded, no illumination remains at all. The great cosmic structures that once blazed with light and energy have long since faded into a soft, all-encompassing darkness. There is no glow of galaxies in the distance now, no radiant nebulae or shining suns, only a deep velvet night stretching out in every direction, endless and still. Space itself has grown vast and lonesome, expanding toward eternity, carrying every remaining particle further and further apart until nothing cohesive remains. Just a thin haze of cold, dim remnants spread through an unimaginable void. Even the ancient afterglow of the Big Bang has been stretched to near oblivion, its faint photons now so few and so feeble that they barely exist. In this profound stillness, time itself seems to slow to a near standstill, as though the cosmos is holding its breath in the endless dark. Without stars or galaxies, or even the faintest whisper of heat, the fabric of reality has become perfectly uniform and empty. If you were to drift here in this final epoch, you would find almost no signposts by which to measure the passing of time. You would be enveloped in a darkness and quiet so absolute, it would feel almost sacred. No air or medium to carry any sound. No distant light to give a sense of direction. Your own heartbeat, if one could still hear it, might be the loudest and only rhythm in an infinity of hush. There are no more day and night cycles, no seasons, no ticking of clocks or cosmic events to punctuate the endless ages. All around is an abiding quiet, the black of space scarcely interrupted even by the feeblest glow of energy. Occasionally, perhaps a lone particle or a wayward photon might wander through the vast void, but its lonely journey goes unnoticed in the grand stillness. Everything has thinned out to near nothingness. The universe is an almost perfect vacuum of existence. In this unimaginable expanse, the chance of two stray particles ever meeting is vanishingly small. Each simply journeys on, alone, with nothing left happening, no change, no motion. Each moment blends into the next, until even the distinction between moments fades, and time loses any meaning it once had. It is an endless night with no coming dawn, where even the concepts of before and after grow dim. This is the heat death of the universe, the final nightfall that follows the last flicker of the last light. It is the fate long predicted by the laws of thermodynamics, a state of maximum entropy, where all useful energy is spent. All differences in temperature have evened out. Every corner of existence is as cold and dark as every other. In this perfectly balanced silence, there is no arrow of time left to point the way. For the arrow of time was drawn by change, and here change has ceased entirely. One could say the universe has finally fallen asleep in an eternal night, dreaming perhaps in slow, diffuse thoughts of all that came before. Just as an aging mind might drift through memories in deep slumber, the cosmos in this state could be imagined to quietly remember the blazing days of its youth. It is a strange and ghostly equilibrium, not the lively balance of a bustling cosmos, but the static poise of almost nothingness. It's like a pendulum that has come to rest after eons of swinging. No more oscillations, no more momentum, only a profound stasis that feels both infinitely heavy and feather light. The universe's long story has reached a pause. And in that pause, everything is eerily calm. Yet, in this immense quiet, the mind cannot help but wonder, is this truly the end? Is this dark, motionless expanse the final chapter of existence? Or could something stir again after this long pause? The emptiness feels so complete, and yet the story of the cosmos has always been one of constant transformation. From the fiery births of stars to their gentle fading, from the clustering swirl of galaxies to their eventual dissolution into darkness, every ending has given rise to something new. Dying stars seeded the galaxies with fresh elements for new stars and planets. Even black holes, in their slow evaporation, returned their energy back to the void. It seems that in the universe, no death has been without some form of rebirth. Perhaps even this ending, this death-like stillness, contains the seeds of another beginning. In the silence, it is almost as if one can hear a faint echo, a subtle hint in the void, suggesting that nothing is truly ever lost, only changed. Like an ancient principle whispered by nature itself, nothing is lost, nothing is created, everything is transformed. So maybe this is not a terminus after all, but a still moment before a new story begins. Somewhere in the depths of this endless void, possibilities glimmer softly, like the memory of starlight in a universe that has forgotten stars. The cosmic canvas is empty now, but an empty canvas naturally invites new pictures. Even the vacuum is not truly nothingness. Quantum physics tells us that tiny fluctuations, like ephemeral sparks, dance in and out of existence, even in the darkest quiet. It might take unimaginable epochs, stretches of time so vast that to human minds they are indistinguishable from eternity. But perhaps one of those sparks could ignite something again. Perhaps a random fluctuation, a momentary alignment of what little remains, could tip the universe out of its slumber. It would only take a tiny event, a quantum whisper in the dark, a minuscule pebble dropped into the still lake of nothingness, to send ripples through space. That ripple could grow, gathering energy, pulling together the fabric of space into a new form. If even a single point of higher order emerges from the chaos, it could blossom outward, inflating into a vast structure. What might it be? Perhaps a new Big Bang, a rebirth of everything from virtually nothing, the cycle starting anew in a sudden, miraculous dawn of light and time. From absolute night, a new morning for the cosmos could be conceived. Throughout history, philosophers and visionaries alike have imagined that time might be cyclical rather than linear. They gazed at the repeating patterns of nature, the seasons turning, the tides rising and falling, the orbits of planets returning year after year, and wondered if the entire universe itself moves in grand cycles. In many ancient myths, the cosmos is born, dies, and is born again endlessly. For example, in Indian cosmology, the universe goes through infinite epochs of creation and dissolution, as regular as the inhalation and exhalation of a cosmic breath. Elsewhere, legends of phoenixes rising from ashes or gods recreating the world after its end hint at this same idea. that existence renews itself. Modern cosmology, too, has contemplated cycles, scenarios of oscillating universes that expand outwards, then collapse back in a big crunch, only to explode in a new Big Bang, an eternal series of bangs and collapses without a true beginning or end. Other theories envision that a universe's end might directly become the next universe's beginning, even without a collapse, like a circle where the end of the loop touches the start. As we float in the darkness beyond the last star, these ideas drift into the mind as naturally as breathing in the cold night. Could it be that after an eternity of stillness, the cosmos will stir once more, and we would find ourselves at the dawn of a new creation? The notion is soothing in its symmetry, an elegant answer to the otherwise unyielding finality of heat-death, a promise that after the longest night, a day will eventually break. One such vision is that of the cosmic phoenix, a universe that arises from the ashes of its predecessor. Just as the mythical phoenix is reborn from its own ashes, one can imagine the universe rekindling itself after going completely dark. Perhaps the end state of maximal entropy, where everything is diffuse and calm, is not a tomb, but a womb, a quiet nursery from which a new universe could emerge. It would be like a seed lying dormant in the cold winter soil, containing within it the blueprint for a new forest, waiting for the right moment to sprout. Some scientists have proposed that if the universe eventually contracts, or if conditions somehow reset at extreme scales, a new Big Bang could indeed follow the final silence, lighting everything up all over again. Others suggest that even without a collapse, the extreme future might connect to a new beginning through physics we do not yet understand, a kind of cosmic recycling, where the end of one epoch seamlessly becomes the start of another. In that view, the boundary between death and birth blurs into nothingness. The universe in its final uniformity might, from another perspective, be the hot, dense germ of a new cosmos. These are ideas on the speculative edge, ways of seeing existence that our current science can only hint at. But they offer hope that beyond the darkness lies something unimaginable, a next chapter waiting to be written when the time is right. Imagine, then, that after eons of quiescence, something subtle changes. Out of the uniform nothingness, a slight imbalance appears, perhaps a tiny field fluctuation, a minuscule region with a touch more energy than its surroundings. In an ocean of darkness, this is like the faintest glimmer of a false dawn. Such a small difference might be enough to tip the cosmic scales. Like a seed crystal forming in a still solution, this tiny spark of order could begin to grow. Slowly at first, it gathers a cloud of energy around it, feeding on the very fabric of space. Space itself, which had been stretching out silently, might begin to ripple and respond to this nascent disturbance. Soon that speck of newborn order inflates rapidly, unfurling new space and time from within itself. This could be a new Big Bang, born not from a mystical singular beginning as we once imagined, but arising naturally from the very end of the previous chapter. A cycle completed, a loop closing only to start anew, turning the end of time into a new dawn of existence. In such a scenario of cosmic renewal, nothing is truly lost. The ingredients of the old universe would become the source of the new one, transformed beyond recognition, but still carrying forth the essence of existence. One could poetically say that the universe breathes, an exhalation into stillness, then an inhalation of a new world. Perhaps countless eons from now, long after this present cosmos has dimmed to nothing, a new cosmos as bright and young as ours once was will blossom into being. If there are new stars in that future sky, they might shine with the recycled atoms of our long dispersed worlds. If there are new living beings, perhaps they will be built from fundamental particles that once were part of us, rearranged into novel patterns. In that way, even in death, the universe would give birth. Through that birth, everything we know would find a kind of immortality, living again in new forms when the cycle turns. Nothing that existed would be wasted. It would all echo again in the new creation, a legacy of the universe that was. The end would give rise to a beginning, and the story of existence would go on. This idea of cosmic cycles is deeply comforting when faced with the idea of eternal nothingness. It suggests that the darkness is never absolute, that somewhere ahead, after the longest night, a morning will come. In other words, infinity need not be an endless void, but could be an endless series of creative renewals. But the notion of cycles invites another profound question. Has it happened before? If our universe might have a second life after heat death, could it be that it was itself born from the remains of a universe before ours? Are we living in one cosmic turn of a great wheel, one iteration among countless others, stretching back and forward through time? The thought expands the mind, almost beyond comprehension. An eternal return of universes, each one blossoming from the quiet seeds of the one before, like a forest where each generation of trees grows from soil, enriched by its ancestors. Likewise, each wave that recedes at the shore makes way for the next to arrive, and so, perhaps each cosmic ending makes way for the next creation. In some modern theories, hints of such a possibility appear even in our observations. For example, it has been conjectured that faint imprints in the cosmic microwave background, the dim afterglow left behind by our own Big Bang, could be scars or echoes from events that happened before our Big Bang ever occurred. It's as if the new canvas of our universe still carries a few markings from an older painting beneath it. Perhaps colossal happenings in a prior cosmos, like the titanic collision of black holes or other massive dances of energy, left traces that survived the death of that universe and seeped subtly into the fabric of the new one. These notions remain highly speculative, residing on the misty border between science and philosophy, but they resonate with an ancient intuition that nothing comes from nothing. Everything that exists now was somehow contained in what came before. Just as the oak is hidden in the acorn, just as tomorrow sleeps quietly inside today. One way or another, it seems that nothing which happens is truly erased without a trace. Modern physics even hints that information, the imprint of every particle and every event, can never be completely destroyed. Even when things fall into black holes or dissolve into the void, the essential information about them might still be encoded in subtle ways within the fabric of space and time. It's as if the universe keeps a quiet record of its history, even if that record gets scattered and scrambled into the most diffuse whispers of energy. So at the end of time, in that thin soup of faint radiation and particles, one could imagine that the memory of the universe lies dormant. Every life, every star, every galaxy that ever shone might have left some kind of imprint on that final state. Perhaps only the universe itself, or whatever comes after it, could ever decipher those imprints, weaving them into a new tapestry. Yet the idea lends a hopeful feeling that no experience, no existence, is completely lost to the abyss of time. In some form, everything is preserved, ready to inspire the next chapter, or at least to be forever part of the cosmic story. Consider the black holes we spoke of, the great devourers of light that once peppered the universe when it was full of galaxies, long before this final darkness. Even in their mysterious demise, black holes might have sown the seeds of new creation. There are speculative ideas that each black hole could, in its unfathomable depths, give birth to a baby universe, a pocket of space that pinches off and expands on its own, cut off from our reality. If that were true, then even before the final black hole evaporated in our universe's death, it might have unleashed new universes, like dandelion seeds floating away, carrying pieces of our cosmos into new realms of existence. Our own universe, by that thinking, could be one such seed, born long ago from a black hole within another parent universe. And in turn, the black holes that once existed here may have become cosmic embryos themselves, each one a potential genesis of a new reality. It's a fantastical thought, a grand family tree of universes branching out endlessly through time, each universe a parent to many children, each child carrying the imprint of its parent in subtle ways. Going one step beyond cyclical time, some theories propose a multiverse in which our universe is one of many. In that view, new universes might bud off from the fabric of reality like bubbles, each expanding with its own space and time. In an eternal inflation scenario, for instance, countless universes could be forming even now in a vast cosmic foam. In that perspective, creation is not a singular event, but an ongoing, never-ending process. Our universe would be just one bubble among an infinite sea of others, a single note in an endless cosmic symphony of worlds. We cannot see or touch these other worlds, but the mere possibility of their existence further expands the scope of the mystery. It reminds us that reality might be far more vast and layered than we can imagine, with creation forever finding new expressions. Drifting in this contemplation, one starts to sense that time need not be a straight line at all, but perhaps a circle, or even an endless spiral. The arrow of time that we experience, from past to present to future, might be just one direction along a loop that eventually curves back on itself. If the universe truly repeats in cycles, then what we call the future and what we call the past could eventually meet. In an eternal recurrence, the future might bring back a reflection of the past. The universe could rewind, in a sense, not by literally reversing physics as we know it, but by progressing forward until it arrives at conditions that mirror the beginning once more. After all, if endless time passes, even the most improbable events become inevitable, given enough chances. Just as a clock's hands eventually return to the top at midnight, and just as the planets return to the same positions in their orbits over and over, perhaps the cosmic story returns to its starting point. Think of shuffling a deck of countless cards for eternity. Sooner or later, the cards might fall back into a previous perfect order. So too, the configurations of the universe could recur, cycling through grand patterns that repeat across eons. If reality does loop in such a manner, then everything we know, every event, every life, every whisper uttered to the stars, could happen again in some distant epoch. It is a dizzying, yet strangely calming idea, that our lives might not be one-offs, but part of an infinite pattern, recurring over and over throughout eternity. You might live again, somewhere, somewhen, not through any mystical reincarnation of a soul, but through the natural cycling of the cosmos, forging you anew out of stardust, once the conditions in some future align to make your existence possible again. All that we are, and all that we do, could be played out again, with no one aware of the repetition, each occurrence just as fresh as the last, and just as real. In essence, this would make our existence both transient and eternal. Transient in each individual life, yet eternal in the pattern that repeats endlessly. What would it mean if you have lived this same life an infinite number of times before, and will live it again infinite times hence? The notion might sound unsettling at first, a bit like being trapped in a loop, but think of it another way. It grants a form of immortality through repetition. Every joy you have ever felt, you will feel again. Every love, every discovery, every warm embrace under the sun will return, as will every night spent in quiet contemplation under the stars. Even the sorrows and trials will recur, yes, but so too will the triumphs, the healings, and the moments of laughter after tears. In such a reality, nothing, beloved, is ever truly lost. Whatever fades in one cycle will eventually bloom in another. In the grand scheme, the pattern of your existence is indelible, etched into the fabric of the cosmos, not just once, but over and over. And yet, because you never remember the previous turn of the cycle, each life is lived anew with genuine curiosity and wonder, unburdened by the weight of its many repetitions. It's as if the universe itself loves to revisit the story of life over and over, each time cherishing it as something new. In a universe that cycles, the role of memory is peculiar. No memories bridge the gaps between iterations. Each new cycle wipes the slate clean, or perhaps the slate itself is broken and remade. The universe has amnesia between lives, just as we have amnesia between dreams upon waking. This means that even if the dance has played out 1 trillion times before, it retains its freshness and mystery. It is always the first time in experience, if not in truth. There is something oddly comforting in that too. The eternal return doesn't diminish the value of now. It sanctifies it by making now eternal in its recurrence. And what of observation? What of those who watch the universe, like us, trying to comprehend it? There is a paradox here. If the universe repeats, who is there to know it repeats? Within each cycle, observers like us see time as linear and one-directional, remembering the past but not the future. To truly witness the eternal return, one would need to somehow stand outside the cycle, to see the whole wheel of time at once. It would be akin to a reader who can flip through the entire book of history at will, while we, the characters, only experience the story line by line. Such a vantage is beyond our mortal perspective, and perhaps beyond any perspective that can exist within the universe. If there were some consciousness that spanned all cycles, it would be like a cosmic witness that sees every repetition as part of one unending whole. Some might call that perspective the viewpoint of a deity, or perhaps the universe itself, becoming aware of its eternal self. From within the cycle, however, each observer is new and yet not new, living lives that have been lived before, but feeling as if everything is happening just now for the first time. We, in our current existence, could be such observers, traversing a familiar path unwittingly. Yet perhaps deep in the subconscious of the cosmos, or in our own souls, there is a faint memory of having been here before. Sometimes when we gaze at the night sky, filled with stars that have long since died, we might feel a strange nostalgia, an echo of something beyond this life. Could it be the echo of countless lives and universes past? Or is it simply the mind's longing for connection in an indifferent cosmos? The eternal return, whether literal or metaphorical, invites us to think of patterns rather than one-time events. It tells us that forms can re-emerge, even if the substance is new. Consider a simple wave on the ocean. The water molecules that make the wave are different at each moment, but the shape, the pattern of the wave moves onward, seemingly alive. In the same way, the matter that makes you is always changing. Over years, most atoms in your body are replaced. Yet the pattern that is you persists through time, like a standing wave of identity. If such continuity of pattern can happen within one lifetime, why not across cosmic cycles? Perhaps what returns in each new universe is not the exact particles, but the configurations, the relationships, the information, like a melody replayed with new instruments. This brings forth the idea of rebirth, not through matter, but through pattern. In an endless cosmos, eventually the same arrangements of matter and energy could form again purely by chance, recreating the pattern of something that once was. This doesn't require that any physical thing travelled from the past to the future, only that the blueprint of arrangements emerges once more. If the universe is truly infinite in time or cycles through an infinite series, then given enough opportunities, the entire arrangement of particles that makes up the Earth, and each one of us, could spontaneously arise again. It might take an absurdly long time, so long that our minds can't grasp it. But in infinity, even the rarest configuration will occur. In that way, you could be reborn not by your old atoms being magically reassembled, but by new atoms falling into the exact same pattern as once before, like identical snowflakes forming in different storms ages apart. This possibility, remote as it sounds, gives a poetic form of immortality to everything. Every moment lost to the past is not truly lost forever. It can return under the right circumstances. The universe has all the time it could ever need to eventually revisit its previous melodies. Every love story, every gentle rain, every mountain carved by wind, all can happen again, perhaps just as they were, or perhaps with slight variations. The pattern is what matters, not the specific instance. This is reminiscent of how information might persist, even if its medium changes. A story can be told in many languages, yet remain the same story. A song can be played on different instruments and still carry the same tune. So too, the narrative of a life or a world might be written again in the ledger of the cosmos, even if the ink and paper are different. How does one find peace in such thoughts? For it is grand beyond measure to envision, and can make one feel both insignificant and profoundly connected. In the quiet of this final night, perhaps the peace comes from understanding that we are part of something much larger, something that does not truly end. If existence is a pattern that can recur, then in some form we are all eternal, timeless, not as unchanged statues, but as recurring notes in the infinite song of the universe. When one note ends, it may sound again later, blending with new notes into the music of the cosmos. These reflections naturally lead to the ultimate question: what lies outside the cycle, if anything? Is there a state beyond all cycles, beyond time and change entirely, a true eternity, not just an endlessly looping time? Some philosophies and spiritual traditions speak of a timeless presence, a state of being where time dissolves and only an eternal now remains. In a way, the heat death of the universe we described is a physical echo of that idea, a state where nothing happens and time, for all practical purposes, stands still. But physical stillness and metaphysical transcendence are not necessarily the same. The cosmic quiet is like a blank canvas of potential, while the timeless presence spoken of by sages is more like a boundless ocean of pure being. Imagine for a moment that beyond all the ebbs and flows of creation and destruction, there is a quiet awareness that simply observes. It does not change. It does not move with time. It just is. In that state, past, present, and future might all appear at once, or cease to have distinction. It would be a perspective from which the entire history of every universe is like a completed story, like a tapestry where every thread of event and time is visible at once, forming a single magnificent design. Some might call this the mind of God, others the ultimate reality, and others simply a higher dimensional view beyond our comprehension. But perhaps, in the deepest meditation or the stillness of deep sleep, we get a tiny glimpse or feeling of that timeless presence, a moment when we are not entangled in the rush of time, when we simply are, without before or after. As we float in the eternal night of the far future in our imagination, we might also float into this kind of timeless awareness. The boundaries between ourselves and the universe feel thinner here. After all, in a universe empty of distinct objects, what is left to separate observer and observed? Consciousness, if it remains at all in this solitude, might fill the void by its very nature. It could expand without the distractions of form and matter, becoming as vast as the space itself. In doing so, perhaps it touches that transcendence, that feeling of oneness with everything and everywhen. This is a deeply philosophical and speculative idea, that perhaps at the end of time, the universe becomes aware of itself in an ultimate way, or that consciousness merges back with the fabric of reality. Whether or not that is literally true, it offers a comforting symmetry. Intelligence and awareness blossomed in the universe when it was full of energy and life. So maybe in the final darkness, that awareness doesn't vanish entirely, but returns to a latent, diffuse state, woven into the silent space like a lingering memory. Now consider the possibility that our entire journey, from the bright, youthful cosmos of long ago to the silent emptiness of the far future, and all these musings on cycles and simulations and recurrences, is itself just one path among many. Perhaps the reality we know is one iteration of countless possibilities being explored. Here we encounter the realm of cosmic simulation theories. The idea that our universe might be an artificial construct, a kind of grand simulation, adds another layer of wonder to our contemplation. If this is a simulation created by an intelligence beyond our universe, what would the end of the universe mean in that context? Would it be akin to a program reaching its conclusion? The final lines of code executing and then everything returning to a menu, so to speak? Or would the simulation loop, restarting anew with the same parameters, effectively causing a cyclic experience by design? If the universe is a simulation, perhaps the cyclic nature we imagine is not a natural inevitability, but a deliberate reset by its creators. To those outside, the entire lifespan of our cosmos might flash by in what they consider a brief span. Our billions of years compressed into moments of their time. One could imagine scientists or beings in another reality running our cosmos like a long experiment. When the universe goes cold and dark, they might analyze the results and then decide to run it again from the start, maybe with slight tweaks to see what changes. In this scenario, eternal return might be the result of someone hitting the restart button on the cosmic computer. To us inside, it would be as if a new Big Bang occurs out of the void. But in truth, it's just the simulation initializing once more. We would have no way to tell, because all memory is wiped. Each cycle would be a fresh simulation run. It's a surreal thought that perhaps every Big Bang is really just the boot up of a grand program, and every heat death the program's shut down. Even the eeriest, most absolute stillness of the far future might be just an intermediate step, a blank screen before the next run begins. Of course, if that were so, one could further ask, what about the world of whoever runs the simulation? Does their reality have another layer above it? The questions can cascade endlessly, stacking worlds within worlds. But at some point, for our meditative journey, it becomes less important to find a final answer and more soothing to simply ponder the possibilities. Each possibility is like a star in the mind's sky, providing a gentle light of curiosity in the darkness. In truth, whether the cosmos is simulated or organic, cyclical or one-off, the effect for us right now is the same. We are here, in this moment, experiencing existence. The vast timescales and cosmic destinies we imagine are far removed from the immediacy of being alive, breathing, thinking, and feeling in the present. And yet, reflecting on them can bring a sense of perspective that is oddly calming. All the troubles and worries of daily life feel a bit smaller against the backdrop of infinite time and space. When you imagine the universe cooling into darkness over trillions of years, the stress of a single day or the outcome of a single year in a human life seems to recede. Not that our lives are unimportant, each life is a unique expression of the universe, but understanding the immense context can grant a kind of surrender, a gentle acceptance. As we explore these grand ideas, simulation and recurrence, cycles and echoes, we can feel ourselves drifting deeper and deeper into a contemplative, serene state. The mind wanders freely among stars and epochs, yet the body is relaxed, heavy and calm. Each breath can be like the rise and fall of universes, each heartbeat an echo of the cosmic drum that beats once in a trillion years. The slowness of our own restful breathing mirrors the slow expansion of galaxies or the gradual cooling of space. In this way, the boundary between the universe and us dissolves a little. We too carry a universe within, the cosmos reflected in our thoughts. And just as the external universe may have its infinite stillness, within us, there is a quiet space of mind between thoughts, a gap of pure being that we often overlook. In that inner silence, one can find a kinship with the quiet of the late-night cosmos. The dreamlike nature of time starts to make itself known. Think of how in dreams, time can stretch or compress, and entire lifetimes can be experienced in minutes of sleep. Our journey through cosmic time here is itself like a guided dream, a slow tour of eternity taking place in the theatre of the mind. And like a dream, it flows gently from scene to scene, without the need for sharp boundaries or strict logic. We simply observe and follow, letting each image and idea softly transform into the next. We went from the end of the universe to the possibility of a new beginning, to cycles and returns, to simulations and beyond, all in a natural progression, as one might drift from one dream scene to another. The key is that it feels seamless, the same way one current in an ocean flows effortlessly into another. Here, in this story, time itself has become malleable and circular, much like in a dream. We have toyed with the edges of reality, stepping outside the linear timeline to imagine the whole, stepping outside this universe to imagine many, even stepping outside existence to imagine a timeless vantage. This is akin to lucid dreaming on a cosmic scale. But now, just as every dream eventually comes to an end, or transitions into a deeper sleep, our cosmic reverie too comes back to the profound silence from which we started. We return to that image of the universe in eternal night, a vast expanse of quiet and darkness stretching onward. Now, however, we see that darkness with new eyes. What seemed like a void is now rich with potential and meaning. We know that it might be the cradle of another universe, or one pause in a great cyclic rhythm, or perhaps a deliberate quietus before a planned rebirth. Or maybe it is truly the final state, but even as a finality, it is peaceful, not tragic, a final rest after an immeasurably long journey. All the possibilities we entertained cast a gentle glow on the darkness, like faint stars that assure us the night is not empty of stories, even if it is empty of matter. And so we float in the dark, not with fear or sadness, but with a profound sense of calm. In this calm, every concept and every image we have conjured begins to dissolve gently, like mist fading in the first light of morning. We find ourselves not needing to hold on to any particular idea. It is enough to have witnessed them. We have travelled to the end of time and beyond in our minds, and now we can simply be. The universe, in its final stillness, simply is, and we, in this moment of rest, simply are. There is a soft paradox in our journey. By contemplating the end of everything, we have found a gateway to a feeling of eternity in the present. By seeing how time could circle back, or stop entirely, we might feel less captive to its relentless flow. In the vast timeline of the cosmos, our individual lives are tiny, yet they are also reflections of the whole. Each of us is a microcosm, a little universe of thoughts and experiences. And just as we saw the grand universe possibly find renewal or peace, perhaps we too find renewal and peace in each moment. As we prepare to let go of wakefulness and drift into sleep, think of it as a personal echo of the eternal nightfall we've explored. Sleep is a small surrender, a step outside of time in a way. Hours can pass in what feels like an instant when we awaken. We close our eyes and the world fades, much like a universe turning off its stars each night, only to be reborn each morning. Yet we know that after our night's rest, a new day will come, a small cycle of death and rebirth that we experience every 24 hours, mirroring those grand cosmic oscillations. Allow yourself now to sink into that comforting darkness, knowing it is safe and natural. The silence of the late-night universe is here to cradle you, wrapping around you like a soft blanket. In your mind's eye, you might still see the dim afterglow of all the stars that ever were, now distant and quiet. They twinkle not in reality, but in memory and imagination, like the last notes of a lullaby fading out. Let those faint lights guide you into a deep inner peace. They assure you that all is well, that even in endings there is beauty, and even in stillness there is the whisper of a possibility. For now, Let your body follow the universe into stillness. Starting at your feet, allow any remaining tension to simply melt away. Feel a gentle wave of relaxation traveling upward. Through your legs, your hips, your abdomen, and into your chest. Let it soften your shoulders, flow down your arms, to your hands and fingertips. Feel even your neck release its stiffness, your jaw unclench, your face soften. From head to toe, a calm heaviness spreads through you, leaving you fully relaxed, safe, and at peace. You can feel yourself sinking deeper into this comfort with every breath, with every passing moment. Feel the weight of your body being gently pulled, as if by a soft gravity, deeper into your bed or wherever you rest. That gravity is akin to the pull of a black hole, drawing you into a singular calm. Except this is a calm you can return from come morning. It holds you, keeps you safe, and frees you from the need to do anything or be anywhere. Right now, you are exactly where you need to be. Just as the final particles of the universe, in their still ballet, are exactly where they need to be. Everything is in its place in the grand scheme, including you. Breathe slowly, in and out, like the universe, inhaling and exhaling. With each breath out, let go of any remaining tension or thought, releasing it into the cosmic ocean. With each breath in, draw in the tranquility of the sleeping cosmos, filling yourself with it. Notice how soft the moment has become, how each second drifts by like a gentle cloud, barely noticed. This is your time of rest, your own little piece of eternity. Take a moment to embrace this quiet. There is nothing you need to focus on, except perhaps the sound of your own gentle breathing, and maybe the soft beat of your heart. Even that seems slow and calm now, like a faint drum echoing in a vast hall of silence. Let that subtle rhythm soothe you further. Each breath, each heartbeat is steady and unhurried, harmonizing with the stillness around you. In this shared silence between you and the stars, you may sense that you are not alone. You are accompanied by everything we have imagined tonight, by the ghosts of old stars and the glow of possible new ones, by the echoes of past universes and the faint outlines of future worlds. All these spectres and dreams are friendly and quiet. They simply watch with you in reverence of the great mystery. The universe itself seems to watch with you, through you, experiencing its own vastness in the small mirror of your peaceful mind. We have travelled far in our story, witnessing the rise and fall of cosmic eras, and imagining new universes blossoming from the old. We journeyed beyond the borders of reality, pondering simulations and multiverses. We turned our thoughts to the idea of time circling back on itself, and even transcending itself entirely. And now we have gently returned to the personal, to this quiet moment of being. Now it is time to rest in the knowledge that the journey, in some form, never truly ends. It just transitions, transforms, and continues on different levels. Likewise, your waking consciousness will now transition into the transformative realm of sleep and dreams. This too is a continuation, a gentle next phase of your voyage tonight. When we dream, our minds effortlessly craft entire landscapes and narratives in the space of a night. In dreams, we might fly, or visit distant places, or meet people long gone. Our thoughts paint scenes as stars once painted the sky. These dream worlds are brief and ethereal, yet while they last, they feel vivid and real. In a sense, each of us holds a tiny universe within us whenever we dream. A world of our own making that exists for a moment in time. And just as the cosmos cycles through creation and dissolution, our dreams emerge and then fade with each sleep, only to be reborn in new forms when we slumber again. It is a gentle reminder that creativity and renewal are fundamental, from the grand scale of galaxies to the intimate theatre of the sleeping mind. Feel a gratitude, perhaps, for being a part of this magnificent existence, for being a note in the eternal symphony, a thread in the infinite tapestry. Every thought you've had, every curiosity about the cosmos, is the universe contemplating itself. And that is a profoundly beautiful thing. In the end, as in the beginning, there is this unity. You and the cosmos are woven together. The atoms in your body were forged in long-vanished stars, and the thoughts in your mind give those atoms a voice to wonder and marvel. So now, let that voice become quiet. Trust that the wonder continues even in silence. There is nothing more you need to do, nothing more you need to seek right now. The cosmos is at rest at the end of time, and you too can be at rest at this moment in time. Embrace the darkness not as emptiness, but as fullness of peace, the eternal nightfall that comforts the weary. In this darkness, you are cradled by the same forces that guide galaxies and birth stars, the gravity of being, the inertia of time, the breath of space. They lull you now, as surely as they carry the cosmos itself toward its next chapter, whatever that may be. All is quiet, all is well, all is at peace. You are floating in the tender void, where the boundaries between now and forever blur. Let yourself drift there, without fear, without desire, just a pure presence. This is the gift of the night, to release you from all the stories for a while, so you can simply exist in a state of ease, like a traveller who has finally come home after a long journey through space and time. You can set down your burdens and lie back under the starless sky, resting. And as you surrender to sleep, know that this gentle journey will continue in your dreams, or in the simple healing silence of deep slumber. You carry the peace of the eternal night within you now. It will be there when you wake, and you can return to it whenever you need. In the morning, when dawn arrives, it will bring new light and new beginnings in your own life, echoing the cosmic morning that may one day follow the cosmic night. But until then, you are safe in the dark, and the darkness is beautiful and kind. Allow yourself to fade along with the universe's last light, comfortable and at ease. Let the vast, mysterious cosmos sing you to rest with its silent lullaby. Feel the gentle hum of infinity around you, a sound too soft to hear, but felt in the heart, reassuring you that everything cycles, everything changes, Yet something eternal and peaceful underlies it all. In that realization, you find contentment. In the far reaches of time, where starlight has faded to memory, a profound darkness settles. It is a gentle darkness, not one of fear, but of rest. We find ourselves drifting in this cosmic night, weightless and unbound, surrounded by the quiet that follows the last flicker of a dying star. Here, at the edge of eternity, the universe holds its breath. It is the eternal nightfall, the hush that comes when all the songs of creation have been sung, when the fires of existence have burned low. Within this vast night, our thoughts begin to wander, reaching back through ages and stories. In the stillness, ancient tales echo softly. We remember that long before we knew of galaxies or black holes, our ancestors too pondered the mysteries of the end and the hope of renewal. Their myths and dreams come to us now like constellations of meaning in the dark. In one such tale, from the frozen north, there was said to be a final winter without end. In that Norse vision, a great wolf chases down the sun and devours it, swallowing the last light of the sky. The world grows cold and silent. The gods meet their fate amid fire and flood, an event they called Ragnarok, the twilight of everything. And yet, even as that world was consumed, it was not the final end. From the ashes and the waters, a new earth was foretold to rise. Green and beautiful, it would emerge cleansed and reborn when the long darkness passed. A new sun, daughter of the one that was lost, would ascend into the sky. Two human survivors, dawn's first children, would walk upon dewy grass where before there had been only desolation. In this way, the Norse sagas whispered that every ending carried the seed of a beginning, that after the longest night, a morning would follow. Far to the south, under desert stars and the glow of the Nile, another story was told each day and each night. In ancient Egypt, people watched the sun set and imagined their god Ra sailing into the underworld. At dusk, Ra, weary and aged, would step aboard his sacred bark and journey beneath the horizon. All through the night, he would travel through secret caverns and dark rivers, guided by starlight and aided by protective deities. In the depths of midnight, a monstrous serpent of chaos lurked. Apophis, forever coiled and waiting to swallow the sun god and prevent the dawn. But Ra was strong and had faithful companions. With spears of light and words of power, they battled the serpent in the heart of darkness. For a moment, all creation held its breath while chaos and light struggled. Then came victory. Apophis was defeated, cast back into the shadows, and Ra emerged on the eastern horizon. At daybreak, he was reborn as a radiant child, the young sun rising anew. The people saw the morning light and knew that life had triumphed once more over the night. To them, every sunrise was a promise that even after the sun's descent into darkness, it would return, reborn and shining, bringing warmth to the world again. These stories, different in culture and landscape, share a quiet resonance. they speak of darkness not as a permanent defeat, but as a sacred pause before renewal. A long winter ends in spring. A night of peril ends in sunrise. Death is followed by rebirth. The cosmos itself seemed to whisper this truth to those ancient dreamers. Around the world, similar tales emerged, as if humanity remembered something deep and true. That cycles turn, seasons change, and what ends may begin again. In the east, sages and seers looked up at the night sky and sensed the rhythm of the universe. They spoke of kalpas and yugas, vast cycles of time in which the cosmos is born, lives and dies, only to be born again. In one vision, the creator god Brahma opens his eyes and a universe springs into being. Stars ignite and galaxies spin out from the cosmic center. Ages pass, and eventually Brahma closes his eyes and the universe dissolves into nothingness, like a dream that has gently ended. But not forever, for when the divine eyes open once more, creation begins anew in another great cosmic dawn. Some poets in India imagined the universe itself as the breath of a sleeping god. Each exhalation an expansion of worlds, each inhalation a contraction back into the divine. In the stillness of that divine pause, the cosmos rests, as if in slumber, awaiting the next breath of being. Others spoke of a lotus flower floating in timeless waters. They said, Lord Vishnu, the sustainer of life, lay upon the serpent of infinity, and as he dreamed, a lotus bloomed from his navel. In that blossom sat Brahma, who would weave the next world from the threads of Vishnu's dream. To those storytellers, our entire universe was but a lotus in bloom, a brief, beautiful emergence from an eternal ocean. One day, the blossom would close its petals and sink back into the deep, and all would be quiet again. But in time, another lotus would bloom. Creation, dissolution, creation again, an eternal cycle, like day and night, waking and sleeping, the heartbeat of existence. Even the phoenix, that mystical bird of fire, embodies this cosmic principle. When its life approaches an end, the phoenix builds a nest of aromatic wood and sets it ablaze, consumed in bright flames. All that remains is ashes, and from those ashes a new phoenix arises, young and renewed, to live again. How many philosophers and storytellers through the ages have looked to the stars and wondered if the universe, too, is like a phoenix. They imagined that the galaxies could one day burn out or collapse, only for a new cosmos to spark to life in the void left behind, each universe rising from the ashes of the prior in endless succession. This idea that perhaps time is a circle, that existence repeats itself on the grandest scale, has surfaced again and again, an undercurrent in human thought, a hopeful refrain against the finality of death. Now, as we drift here in the quiet of cosmic night, these ancient memories and musings surround us like gentle phantoms. They do not feel like dusty myths of a distant past. They feel alive, immediate, as if the cosmos itself is sharing its old secrets. We listen, and we wonder, could it be true? Is there truly no final end? Will even the darkest night eventually give way to light? Or perhaps, is the universe destined for a different kind of conclusion, one so distant and mysterious that it eluded the ancients' dreams? Our journey carries us further now, not back into history, but onward into the future, into times so distant that the mind can barely grasp them. We leave behind the warmth of familiar stars and venture into epochs yet unborn, imagining what the cosmos might become eons from now. The stars around us are fading, their once brilliant light now dim and few. Galaxies that were crowded with billions of suns now grow sparse and quiet. The universe is aging, and the lively theatre of galaxies and nebulae is slowing down. Time flows onward, millions of years, hundreds of millions, then billions. The dance of star birth and star death that once filled space with radiance begins to falter. The great furnaces of the galaxies, the massive blue stars that burn so hot and brief, have all long since gone out, ending their lives in spectacular supernovae that lit up the darkness. In their wake they left behind neutron stars and black holes, like embers after a bonfire. The medium-sized stars, like our own sun, have swollen into red giants and gently shed their skins to form glowing nebulae, then cooled into white dwarfs, small dense cinders slowly fading. Even the smallest stars, the red dwarfs that burn their fuel so slowly they can shine for trillions of years, one by one, are exhausting their light. In this far future, only the faintest red glow from the longest-lived stars dots the blackness, like the last few coals of a once roaring fire. Drift forward further still, and those last red stars, too, must succumb. Trillions upon trillions of years slip by in silence. Imagine a night so long that the concept of a year loses meaning, where time itself seems to stretch into an endless expanse. At some point, there will be a final star, a lone red glow in a sea of black, the last star of the universe, shining weakly, perhaps watched only by dead planets and the ghosts of long-vanished civilizations. When that final star flickers out, a profound darkness will fill the cosmos, deeper than any night before it. It will be the first true night that the universe has known since the dawn of time after the Big Bang, when the first stars were born. The curtain falls on the age of starlight. Yet even then, something remains. In that darkness float the remnants of what once was. There are the black holes, the strange, hungry gravity wells left behind by giant stars and by the cores of galaxies. Though no star remains to light them, they themselves slowly glow with a ghostly energy. Over eons, black holes very gradually evaporate, releasing a faint haze of particles and radiation. It is a cold glow, on timescales almost inconceivably long. The largest black holes, the ones at the centers of galaxies that once devoured millions of stars, will take countless ages to evaporate, far longer than the age of the universe so far. But one by one, even they will dissolve. It may take 10,000 trillion years. Numbers fail us here. We are beyond the realm of ordinary time. But in this great span, even black holes are not eternal. As the black holes winnow away to nothing, and the last husks of matter decay, the universe approaches a state of ultimate stillness. What remains when a flame has gone out? A wisp of smoke, which itself dissipates into the air. What remains when the cosmos's heat and light have all ebbed? A thin, cold mist of particles, spread so far apart that they rarely meet. All motion slows, then ceases. This is the silence at the end of time, the heat death of the universe. Not a dramatic explosion, but an ever-deepening quiet. A final equilibrium where nothing more can happen because all gradients have smoothed away. Entropy, the long tide that always increases, has reached its distant shore. In this almost perfect disorder, there is no arrow of time, no past or future, only an eternal present that stretches out, unchanging. Such an ending may sound like a sad and lonely fate, a universe exhausted, bereft of light and life, sitting in a starless night forever. But let us linger in this vision and look around with different eyes. Is it truly an end or a kind of cosmic rest? Here, in the stillness, we might sense something profound. In the silence of this heat death, every strife and struggle of the cosmos is over. All the explosions of stars, all the collisions of galaxies, all the births and deaths and dramas have come to a close. What remains is pure tranquility, a quietude so complete that it is like a meditation, as if the universe itself has slipped into a deep and dreamless sleep. In this dark and quiet cosmos, perhaps there can exist a timeless presence, a state beyond the flow of seconds and years. With nothing changing, time itself no longer marches forward. Every moment is alike. In a way, time has dissolved into an eternal now. Could consciousness of some sort experience this endless now? It's a difficult question. If no beings remain, then this piece is unobserved, a blank canvas without an eye to see it. Yet it is intriguing to imagine that maybe something of awareness could persist or arise even in this final night. Some thinkers have wondered whether in the far future life might find ways to endure much longer than we would expect. Not life as we know it. Flesh and blood cannot survive the frozen emptiness, but perhaps life reshaped into new forms. Imagine beings of the far future who foresaw the death of starlight and transformed themselves to survive it. They might have become machines or digital minds, shedding fragile biology for the durability of circuits or some other technology. Over unimaginably long eons, they could hibernate and slow their thoughts to a crawl, awakening briefly to gather energy from fading sources, then dreaming away millennia to conserve power. Perhaps in the epoch of the last stars, there were artificial minds orbiting those faint embers, capturing every last photon of light to feed their ponderings. As the universe grew colder, those minds might have clustered around black holes, tapping the trickle of energy that those black holes slowly release. Picture them encircling a black hole like travelers around a small campfire. The black hole's faint glow, their only warmth in the vast night. They communicate rarely, perhaps sending a single message across the darkness once every century, then once every millennium, eventually once every million years. As energy becomes ever more precious, their thoughts slow down, stretching time internally so that a single second of thought might correspond to years of the outside universe, then centuries, then millennia, all to savor what little life remains in the cosmos. What would such ancient, patient minds think about in the dark? Maybe they recount the history of the stars, telling stories of the galaxies and civilizations that came before. Maybe they sing quiet songs to one another across the void, songs of memory and longing, to remind themselves that they are not entirely alone. Or perhaps, having witnessed so much, they meditate on deeper truths, coming to insights we cannot fathom, or simply watching the final physics of the universe play out with a sense of acceptance and wonder. One can imagine a time when even these last minds must finally face the end. The energy to keep thinking, even slowly, will dwindle to nothing. One by one, the artificial lights will wink out. Perhaps they go willingly, after long contemplation, like sages stepping beyond the mortal veil. In the dark, maybe only one solitary consciousness remains, the very last being in the universe. This last witness drifts through the endless night, cherishing the final thoughts possible. It might use its remaining energy to ponder the greatest mysteries one last time. Perhaps it turns inward, searching its vast memory banks for meaning, for some answer to why the universe was, and whether something lies beyond this silence. In a poignant image, we might think of that last mind closing its equivalent of eyes, letting its final thoughts flow in a gentle stream until the stream runs dry. And then, for a moment, there is truly no thing left but darkness and quiet. A universe without any minds to know it, without life or light. A slumber as deep as existence can offer. If one were to stand outside of time and look at this state, would it be dreadful nothingness or a kind of completion? Perhaps it could be both, or neither. Perhaps it is peace. There is a concept in spiritual philosophy that comes to mind: nirvana. In Buddhism, nirvana is often described as the extinguishing of a flame, not a physical fire, but the quenching of the fires of desire, attachment, and suffering. It is a state beyond our common notions of existence, a liberation from the wheel of rebirth, a peaceful nothingness or no-thingness. Some might visualize it as a candle flame being gently blown out, leaving behind quiet and darkness, but a darkness that is serene, not sad. In the silent, motionless universe at heat death, one can find a striking parallel to this idea. The cosmic flame has gone out. All desires and strivings of matter and energy have ceased. The universe has, in a sense, attained nirvana, a state free from turmoil and change. It is a final release from the turbulence of creation. If there were an intellect still present to witness it, would it find this ultimate quiet to be blissful? Or is bliss only meaningful to those who once knew suffering and noise? The questions drift away unanswered, dissolving into the stillness. In nirvana, it is said there is neither self nor non-self, neither being nor non-being. Likewise, in the heat-death state, our categories of something and nothing blur. There is no active cosmos as we know it, but the substrate of space and the residue of energy still exist in a thin whisper. It is not absolute nothingness, yet it is a state where nothing ever happens. A stillness that is, in effect, outside the story of time. However, not all spiritual traditions end in quiet extinction. Many offer the promise of renewal or rebirth, a cosmic reincarnation. Just as our ancient myths spoke of cycles, so too have philosophers, and even scientists, speculated that the ultimate end might be a doorway to a new beginning. Perhaps this endless night is not truly eternal. Imagine that after uncountable eons of stillness, a random fluctuation, a quantum spark, flashes out of the darkness. It could be small at first, hardly noticeable, but if conditions are right, it could grow. Maybe it becomes the seed of a new order, a new low-entropy pocket within the chaos. From nearly nothing, a new Big Bang could erupt, giving birth to a fresh cosmos in a burst of light and time. It's a wild thought, but not so different from the phoenix or the lotus or the new sun after Ragnarok. Modern cosmology has its own myth-like ideas. Some researchers have pondered whether the death of one universe could lead to the birth of another. Perhaps the collapse of a previous cosmos could have been the trigger for our Big Bang. Or perhaps black holes in our universe spawn baby universes beyond our observation. There are even cyclic models, a universe that expands for a time and then contracts in a great collapse, only to rebound into a new Big Bang, over and over, forever. Our current scientific understanding doesn't confirm any of these cyclical fantasies, but in the quiet of this thought journey, we can entertain them as possibilities, like distant perhapses glimmering in the void. Consider the idea of eternal return, a concept that fascinated some philosophers. In an infinite expanse of time, could it be that everything repeats? If the universe is truly infinite and unending, perhaps someday, by sheer chance, the same conditions will align again, and a cosmos just like ours will bloom once more. Every star, every planet, every life, even you, might occur again in the far, far future, as if time were a wheel turning through possibilities. It's a dizzying idea, that the night might eventually circle back to another dawn that is strangely familiar, that we might all live again in another eon, none the wiser that we had done it all before. This eternal return is as much a poetic idea as a scientific one, but it lingers in the mind, an echo of the human hope that nothing beautiful is ever truly lost, only waiting to be found again in a different time. And then there is the thought that, at the end of all things, one might encounter the divine, that the universe's story might end where it began, in the embrace of a creator or an all-encompassing consciousness. Some mystics have imagined that the end of the universe is a grand return, a homecoming to the source of all existence. In this view, the long journey of stars and life is a kind of grand play or exploration, and when it's over, everything folds back into the one, into God, into a singularity of spirit. It is a comforting notion that we all, and everything we know, are ultimately a part of a greater whole, and that after experiencing separation and the adventure of life, we go back to unity and rest within that wholeness. One could liken it to droplets of water that evaporate from the ocean and travel through the clouds, only to rain down and eventually flow back to the sea. In the end, they are one with the ocean again. So too, perhaps, with souls or with the essence of being, returning to an ocean of consciousness when the cosmos comes to its final stillness. All these ideas, rebirth, reincarnation, eternal return, nirvana and divine reunion, swirl around us as we float in the darkness. Which, if any, is true. The universe keeps her secrets, but there is a profound solace in contemplating them. We see that even in confronting the end of everything, human imagination finds not just endings but transformations. It finds a way to see light in the dark, meaning in the silence. Slowly, our awareness drifts back to the present moment within this narrative. We are still in the void of deep time, but perhaps we sense that the journey is reaching a resting point. We have travelled through myth and science, through the fears of our ancestors and the conjectures of our descendants. We have visited the death of the sun and the birth of a new world in story. We have sat with the last particles at the end of time. We have imagined minds enduring in the darkness and the universe achieving a final peace. We have watched the cosmos die and imagined it dreaming again. In this meditative darkness, we come to realize something gentle and reassuring, that even the end of the universe can be seen as natural and okay, just as night is a natural counterpart to day, just as sleep is the sister of wakefulness. The stars do not worry as they exhaust their fuel. They simply shine while they can, and then yield their matter to form new stars. Galaxies collide and merge, then eventually spread out their contents to the interstellar winds. Everything transforms. And so, too, will the universe itself transform or find rest. It is the great cosmic cycle, or perhaps the great cosmic journey from birth to stillness. And maybe that stillness itself, as empty as it might appear, is not something to fear, but something akin to a deep cosmic sleep. As we float here, a tiny consciousness contemplating all of time and space, we might feel a sense of kinship with the cosmos. Our own life is a smaller echo of these themes. We are born, we grow, we pass through days and nights, joys and sorrows, and one day we will face our own end. But along the way we find renewal in so many forms. In each morning we wake from sleep, in each spring that follows winter, in the smiles and laughter that follow tears. We have our own cycles of light and dark, activity and rest. And at night, when we lay down to sleep, we are not frightened that the day has ended, because we trust that a new day will come, and that in the meantime, we will find comfort in the restful darkness. So perhaps we can think of the universe's long journey in the same compassionate way. If one day it must sleep, then perhaps that sleep is sweet after the toil of billions of years. If one day it must end, perhaps that ending is but a transition, something beyond our understanding but not necessarily bleak. Even in endings, new possibilities can be hidden, like stars waiting behind the curtain of night. Now, our minds grow quiet, having roamed across eternity. The images of gods and cosmic beings, of stars and black holes, begin to gently fade into a soft blur. We do not need to hold on to them tightly. We can let them drift. In this moment, we simply abide in the silence and wonder we have created, comfortable with the vast unknown. There is a feeling of being cradled by the darkness, the same darkness that falls each evening on earth, the same darkness that the ancients watched and filled with stories, the same darkness that will one day fill the space between dead galaxies. It is the darkness of rest, of potential, of mystery. Feel the calm of this cosmic night. It is as though the universe itself has exhaled, and we are floating on that breath, suspended in a timeless sea. Nothing is asking anything of us here. We are simply present, witnesses to the grandeur of all that has been and the enigma of what may be. In this space, beyond past and future, we feel a gentle connection to everything, to the first dawn and the final dusk, to the first living cell and the last thinking machine, to the child watching a sunrise and the sage contemplating eternity. All of it is part of the same great story, the story of being. And for now, we rest in a quiet chapter, one between the stars and the void, listening to the silent music of time. Perhaps, as we prepare to leave this contemplation, we carry with us a subtle peace, a trust in the process of cosmic life and death. The night is long and vast, but it is not empty of hope. Whether the universe will ignite anew or remain in tranquil silence, there is beauty in both outcomes. Either the story continues in another form, or it concludes in a graceful fade out. In either case, the journey has been magnificent, and we have been a part of it. Here, at the end of this exploration, we surrender to the unknown. We allow ourselves, like the universe, to simply be. If thoughts arise, they float by like distant galaxies, and we let them go. If emotions stir, we acknowledge them and let them become still. We are floating in dark, comfortable space, with the whole of time behind us and an open eternity ahead. And as we gently return from this voyage, perhaps to the soft bed where we lie listening, to the quiet room around us, we do so slowly, keeping the calm and the mystery within. We remember that darkness can be gentle, that endings can lead to beginnings, and that in the deepest silence there is wonder. In this peaceful state, we take one more moment to linger in the eternal nightfall, that vast cosmic dusk we have been exploring. It is no longer something distant and cold. It feels almost familiar and tender, like a lullaby sung by the stars. Let it lull you now. Let the darkness wrap around you like a warm blanket. Feel the assurance that just as night falls, morning comes, and beyond every ending, something new awaits, even if we cannot yet imagine it. For now, rest, drift, and let your mind be as the universe in its quiet hour, expansive, mysterious, and at peace. The journey continues, but for tonight, we have travelled far enough. In the silence that follows, in the gentle darkness, find your own place of comfort among the stars and the infinite night, and let yourself sleep, cradled by the cosmos and its endless story.